Picture a sprawling, silent storm of heavy dust and vibrant gas completely suspended in the absolute zero of deep space. These colossal, glowing clouds span hundreds of light years across the expanse, acting not as empty fog, but as the very cradles where new solar systems are meticulously forged. A soft, warm light begins to softly pierce the chilling darkness, signalling the violent, beautiful ignition of a newborn star waking up in the cold. Deep within the crushing gravitational grip of a distant gas giant, a foundational heartbeat pulses beneath the frozen, scarred exterior of an alien moon. An unimaginably massive global ocean of liquid salt water is hidden entirely beneath this cracked shell of unyielding ice, churning quietly in total lightless isolation. This submerged aquatic world holds more than twice the volume of all the oceans on our own planet combined, kept warm only by the relentless rhythmic squeezing of gravity. Surprisingly, as we gaze outward from our own small blue threshold into this dizzying expanse, we are met with a profound, almost heavy stillness. The galaxy should logically be teeming with the noise, architecture, and light of countless ancient civilizations, yet we find ourselves standing in a hauntingly quiet void. We are left to wonder if we are the very first minds to awaken, or if the cosmos is keeping a dark, terrifying secret hidden in the shadows between the stars. If we were to look closer at this exact moment in time, we would find that the safest place in the entire universe is right where you are resting. The chaotic storms of the cosmos are millions of light years away, leaving you completely secure and anchored by the soft, steady rhythm of your own breathing. You are safe, and these majestic wonders are yours to inherit as you sleep, a grand tapestry of creation unfolding entirely for your peaceful contemplation. In the quiet, freezing depths of the cosmos, vast and silent dust clouds drift through the interstellar void. These colossal nebulas, spanning hundreds of light years across the dark expanse, are not merely empty fog, but the very cradles of future solar systems. Soft, warm glows begin to permeate the chilling darkness as gravity slowly takes hold of the scattered hydrogen and helium. Over millions of years, swirling clouds of gas and dust collapse under their own immense weight, drawing material tighter into dense, rotating cores. The pressure at the centre of these collapsing pockets builds to an incomprehensible degree, generating intense friction and escalating temperatures. A profound transformation occurs in the silent void as the kinetic energy of falling gas converts into blinding thermal radiation. When the core temperature breaches millions of degrees, nuclear fusion violently ignites, and a new star is born into the universe. The sudden burst of radiant energy pushes back against the crushing force of gravity, establishing a delicate, luminous equilibrium. This newborn sun instantly bathes its surrounding dust cocoon in majestic light, painting the stellar nursery in vibrant hues of crimson and gold. Deep within the Orion Nebula, a breathtaking cosmic factory operates on a scale that defies human comprehension. The glittering stellar nursery, illuminated by the fierce ultraviolet light of massive young stars, conceals a profound chemical secret in its cooler, denser regions. Here, in the shadowy ridges of gas, the universe is actively brewing the very elixir of biological life. Astonishingly, water molecules are being created in massive quantities, far exceeding the volume of all the oceans on Earth combined. Microscopic grains of silicate dust serve as floating anvils, where stray oxygen and hydrogen atoms collide and bind together in the freezing dark. The harsh radiation from nearby newborn suns periodically heats these icy grains, sublimating the freshly forged water into a gaseous vapour. This invisible, hydrating mist flows outward through the nebula, eventually cooling and freezing onto the surfaces of nascent planetary disks. The sheer abundance of this celestial water reveals that the fundamental ingredients for habitable worlds are not rare anomalies. Instead, the cosmos is dripping with the potential for oceans, quietly waiting for rocky seeds to catch the falling cosmic rain. Surprisingly, some stars are born completely alone in the pitch-black voids between massive galaxies, far removed from any bustling stellar nursery. These solitary sentinels ignite in the ultimate cosmic isolation, surrounded only by the haunting emptiness of intergalactic space. While most stars form in the crowded, gravitationally bound neighbourhoods of galactic disks, these orphans trace a different, far lonelier origin story. They are the product of immense gravitational tides that occasionally rip vast trails of gas away from interacting galaxies. When two majestic spiral galaxies pass too closely in a slow-motion collision, they can cast off long, wispy tails of raw, star-forming material into the dark. Within these isolated tendrils of orphaned gas, dense knots can still form and collapse under their own gravity. The resulting stars burn brightly in the absolute void, casting their lonely light into a surrounding darkness that stretches for millions of light years. Any planets fortunate enough to form around such isolated suns would possess a night sky completely devoid of other stars. Their inhabitants would gaze up into an endless, terrifyingly empty blackness, entirely unaware of the magnificent swirling island universes scattered across the deeper cosmos. The majestic pillars of creation, often perceived as solid monuments of the cosmos, are actually towering tendrils of star-forming material. These iconic, light-year-long structures are composed entirely of frigid molecular hydrogen gas and microscopic cosmic dust. They stand as ephemeral silhouettes, deeply carved and sculpted by the relentless, blistering winds of massive neighbouring stars. A relentless torrent of ultraviolet radiation from nearby stellar giants continuously batters the edges of these dark towers. The fierce light slowly boils away the thinner outer layers of gas in a destructive process known as photoevaporation. Yet tucked safely inside the densest, most resilient tips of the pillars, localized pockets of gas continue to stubbornly collapse inward. Hidden from the destructive glare, embryonic stars gather mass in the protective shadows of their dusty cocoons. The soft, warm glow of these hidden stellar nurseries occasionally peeks through the dissolving walls of the pillars, signalling life amidst the destruction. Eventually, the very radiation that shaped these breathtaking monuments will erode them entirely, leaving behind only the bright, newly ignited suns that gestated within their dark hearts. Long before our own sun ever drew its first breath, ancient supernovae violently seeded the universe with the heavy elements necessary for rocky planets. The primordial cosmos consisted almost entirely of simple hydrogen and helium, possessing none of the complex building blocks required for solid ground. It took generations of massive, short-lived stars to act as the colossal nuclear furnaces of the early, expanding universe. Within their crushing, superheated cores, these titan stars forged carbon, oxygen, silicon, and iron through relentless atomic fusion. When they inevitably exhausted their nuclear fuel, their cores collapsed in a fraction of a second, triggering an explosive rebound of unimaginable power. The resulting supernova detonation outshone entire galaxies, shattering the star and violently expelling its enriched guts into the surrounding void. This celestial shrapnel drifted through the darkness for eons, eventually mixing into the quiet, silent dust clouds of future stellar nurseries. The iron in our blood, the calcium in our bones, and the very ground beneath our feet were all born in these ancient explosive deaths. We are quite literally the awakened, walking remnants of shattered stars, built from the catastrophic debris of the early cosmos. Picture a binary star system where two suns cast double shadows on the surface of alien orbiting worlds. In this dynamic gravitational dance, twin stars circle a common centre of mass, locked in an eternal sweeping embrace. The sky of such a planet would be a breathtaking theatre of light, featuring shifting colours and deeply complex interlocking eclipses. As the two stars possess different masses and temperatures, one might burn a fierce, piercing blue, while the other glows a soft, cooler orange. Depending on the planet's position in its orbit, these twin suns would slowly drift apart in the sky, stretching shadows into long, overlapping geometries. the gentle warm light of the stellar nursery would have yielded a highly complex climate, driven by the fluctuating radiation of a double-engine solar system. A sunset on this world would not be a simple descent into darkness, but a prolonged, spectacular transition of fading colours. One sun might dip below the horizon, plunging the landscape into a deep twilight, only for the second sun to maintain a lingering vigil. Life evolving beneath such a sky would choreograph its biological rhythms to a beautifully erratic, dual-pulsing heartbeat of light. Far away from the blinding brilliance of standard stars, brown dwarfs emit a faint magenta glow as they slowly cool over billions of years. These curious celestial objects represent the quiet, forgotten failures of the stellar nursery, hovering in the liminal space between the heaviest planets and the lightest stars. They managed to gather more mass than a gas giant, but ultimately failed to trigger the sustained nuclear fusion required to shine brightly. Lacking the internal fire of a true sun, a brown dwarf is born with a finite reservoir of residual heat from its initial gravitational collapse. In their youth, they briefly fuse a rare isotope called deuterium, glowing with a sullen, dark red luminescence against the void. However, this meager fuel supply is rapidly exhausted, leaving the cosmic misfit to slowly radiate its remaining warmth into the freezing vacuum. As the eons pass, the object dims and cools, shifting from deep red to a ghostly, almost invisible magenta or dull purple. Complex weather systems, including vast storms of molten iron rain and silicate clouds, churn violently in their thick, darkening atmospheres. They are destined to wander the galaxy as eternally cooling embers, a silent testament to the strict mass requirements of stellar ignition. Once a new star fully ignites, its gentle stellar winds act as cosmic brooms, actively clearing away the primordial planetary dust. The violent birth of a sun leaves its immediate surroundings choked with a chaotic, swirling debris field of leftover gas and microscopic rock. If this dense fog were to remain, it would continually spiral inward, eventually suffocating the newborn planetary bodies or dragging them into the fiery core. Instead, the young star begins to exhale a continuous, powerful stream of charged particles and high-energy photons into the empty void. This outward pressure physically pushes against the lighter elements of the surrounding nebula, slowly driving the obscuring mist away from the inner solar system. The soft, warm glow of the stellar nursery is eventually blown back, revealing the crisp, sharply defined orbits of a newly stabilized planetary architecture. This sweeping wind permanently dictates the chemical composition of the surviving worlds based on their precise distance from the central heat. Lighter gases like hydrogen and helium are blown far into the outer, freezing reaches, where they are captured by massive giant planets. Meanwhile, the heavier, stubborn rocky materials remain close to the star, settling into the warm terrestrial spheres we recognize as home. Hovering in the galactic halo, globular clusters pack millions of ancient stars into a densely sparkling, perfectly spherical swarm. These breathtaking celestial cities are among the oldest structures in the entire universe, containing suns that ignited when the cosmos was barely in its infancy. Unlike the loose, scattered stellar nurseries of the modern galactic disk, these massive clusters are incredibly tightly bound by immense mutual gravity. If a planet were to somehow survive in the core of a globular cluster, its night sky would be an overwhelming canopy of pure brilliance. Millions of neighbouring stars would blaze with the intensity of a full moon, completely erasing the darkness of night and drowning out the deep void. The extreme proximity of these suns means that stellar encounters are frequent, with wandering stars occasionally stripping planets away from their rightful orbits. Because they formed so early in cosmic history, these ancient stars are incredibly poor in heavy elements like iron and stable silicon. The primordial dust clouds that birthed them had not yet been enriched by the countless supernova explosions of later generations. Consequently, rocky terrestrial planets are likely vanishingly rare within these densely packed glittering spheres of pure hydrogen and glowing helium. In its turbulent infancy, a young star often spins rapidly while emitting peaceful, parallel jets of glowing plasma into the dark. The immense gravitational collapse that forms the star also dramatically amplifies its rotation, much like a figure skater pulling in their arms to spin faster. This intense, dizzying rotation generates powerful magnetic fields that become violently twisted and coiled around the young star's glowing poles. As leftover material from the stellar nursery falls inward onto the star's equator, a portion of this gas is caught by the magnetic maelstrom. Instead of being consumed, this superheated matter is aggressively funneled outward and launched from the polar axis at phenomenal, blistering speeds. These narrow, beautifully straight jets of ionized gas can pierce through the surrounding nebula for light years, glowing fiercely as they collide with interstellar dust. Over millions of years, this dramatic ejection of mass serves a vital mechanical purpose, helping to bleed off the star's dangerous rotational energy. Without these glowing exhaust valves, the newborn sun might simply spin itself apart before ever achieving a stable, mature equilibrium. Eventually the rotation slows, the magnetic fields relax, and the young star settles into the quiet, steady rhythm of its adult life. As the young star settles into the quiet, steady rhythm of its adult life, the chaotic debris left behind begins to organize into the rhythmic, silent orbital dance of diverse planets. Among the most extreme architects of this new cosmic system are the hot Jupiters, colossal gas giants that migrated far inward from their freezing birthplaces to park perilously close to the central sun. These gargantuan worlds are locked in a torturous, blistering embrace, circling their parent stars at distances so short that a single year lasts only a matter of mere days. The sheer proximity to the stellar furnace subjects these massive planets to unimaginably brutal temperatures, heating their gaseous envelopes well past the melting point of rock. Under this relentless, searing thermal assault, their thick, swirling atmospheres physically expand and violently boil away into the freezing vacuum of deep space. Tremendous supersonic winds whip across the blistering dayside, driving vaporized heavy metals and shimmering silicates toward the permanent night side, where they precipitate as howling storms of molten iron rain. Plumes of escaping hydrogen and helium are aggressively stripped from the planet's bloated upper atmosphere by the merciless, sweeping stellar winds. This fleeing, superheated gas trails behind the doomed giant like the magnificent glowing tail of a gargantuan comet, leaving a vast, visible scar across the inner solar system. Over billions of years, this steady atmospheric hemorrhage could eventually strip the hot Jupiter of its thick, gaseous envelope entirely, leaving behind only the scorched, barren, metallic core of a slowly dying world. Far beyond the warm, organizing light of any central sun, rogue planets wander the pitch-black galactic wilderness in absolute freezing isolation. These nomadic worlds were once part of a bustling planetary system, born within the crowded, swirling disks of early stellar nurseries. However, chaotic gravitational interactions with passing stars or massive sibling planets aggressively ejected them from their rightful orbits, violently casting them out into the endless dark. Stripped of their parent star, these exiled wanderers quickly lose their surface heat, their global oceans freezing solid into miles-thick armour of unyielding ice. The atmosphere, once vibrant and circulating, collapses into a frigid static shell of frozen gases clinging desperately to the darkened crust. Yet, deep beneath this frozen exterior, the slow, steady decay of radioactive elements within the planet's rocky core may still generate a faint, persistent internal warmth. It is comforting to know that as you rest safely here, anchored by gravity and bathed in sunlight, the universe hides these silent, invisible travelers drifting through the abyss. If a rogue planet possesses a thick enough atmosphere or a deeply buried ocean, that geothermal heartbeat could theoretically sustain strange, blind ecosystems entirely cut off from the light of any star. They drift forever as phantom worlds, ghost ships sailing the vast interstellar oceans without a destination, bound only by the gentle, sweeping currents of the galaxy's broader gravitational pull. Notice how the chaotic pinball game of the early solar system eventually gives way to astonishing mathematical harmony as planets settle into their permanent grooves. Deep within certain tightly packed planetary systems, resonance chains lock multiple worlds into perfectly synchronized, mesmerizing orbital ballets. This phenomenon occurs when the gravitational pulls of neighboring planets slowly nudge one another over millions of years until their orbital periods form neat, whole number ratios. If we were to look closer at such a system, we would see a breathtaking clockwork precision where the inner planet completes exactly 3 orbits for every 2 orbits of its neighbour. These rhythmic gravitational handshakes constantly tug and correct the planets, preventing them from violently colliding or being flung out into the freezing void. The resulting orbital dance is a beautiful self-correcting mechanism that stabilizes the entire architecture of the alien solar system against the creeping chaos of deep time. When these planets align in their precise conjunctions, the combined gravitational pull briefly flexes their solid rocky crusts, generating internal friction and heat. This gentle rhythmic squeezing can fuel active volcanoes or maintain hidden subsurface oceans, ensuring the worlds remain geologically alive despite their distance from the Sun. The silent music of these orbital spheres dictates not just the paths they travel, but the very geological pulse beating within their deep, rocky hearts. Long before these harmonized orbital chains can form, the raw building blocks of planets must first gather within flat, swirling protoplanetary disks that resemble giant spinning records made of pebbles and ice. As the newborn star greedily consumes the bulk of its parent cloud, the leftover material flattens out along the star's equator due to the relentless momentum of its rapid spin. This vast rotating platter of microscopic dust and frozen gas extends for billions of miles, casting a dark, silhouetted shadow against the vibrant glow of the stellar nursery. Within this dizzying carousel of debris, microscopic grains of silicate and ice begin to collide and stick together through the gentle force of static electricity. Over millions of years, these tiny agglomerations grow into larger jagged pebbles, which then relentlessly crash into one another to form mountain-sized boulders known as planetesimals. The spinning record is slowly swept clean as these massive rocky snowballs plough through the dust, carving wide, empty gaps that signal the unmistakable birth of true planets. The composition of this spinning disk drastically changes depending on the distance from the central, burning heat of the young star. Close to the stellar fire, only resilient rocks and heavy metals can survive the blistering radiation without instantly vaporizing into nothingness. Further out, beyond the invisible freezing boundary known as the snowline, delicate water ice and frozen ammonia accumulate in massive quantities, providing the necessary bulk to eventually build towering gas giants. Among the rocky survivors of this chaotic accretion process, super-Earths offer vast, sweeping landscapes dominated by a gravitational pull much stronger than our own. These massive terrestrial worlds blur the traditional dividing line between small rocky planets like our own and the swirling gaseous behemoths of the outer system. While they share the solid ground we're familiar with, their sheer mass means their atmospheres are often crushing, thick blankets of heavy, suffocating gases. The intense internal pressure generated by such immense gravity forces their geological processes to operate on a scale far more violent and rapid than anything ever witnessed by humanity. Towering mountain ranges could be thrust upward and aggressively eroded away in a fraction of the time, while massive churning continents race across a turbulent superheated mantle. The oceans on a super-Earth might not be made of gentle lapping water, but rather exotic, highly pressurized fluids that exist in a bizarre state halfway between liquid and gas. As your body relaxes against its supports, feeling the gentle, familiar pull of our own planet's gravity, consider how vastly different life would be under such a heavy cosmic yoke. Flora and fauna evolving on a super-Earth would likely be low to the ground, densely muscled, and incredibly resilient to survive the relentless downward drag. The sheer effort required merely to stand upright would dictate the entire biological architecture of the world, creating a biosphere built purely for endurance against the crushing weight of its own home. Picture a haunting, divided reality where tidally locked worlds feature one hemisphere of eternal, blistering day and another of endless, freezing night. This dramatic planetary fate is sealed when a world orbits too closely to its host star, allowing the star's immense gravity to act as a permanent gripping brake on the planet's rotation. Eventually, the planet's spin perfectly synchronizes with its orbital period, forcing it to forever bear the exact same face to the relentless burning fire of its sun. On the sunward side, the merciless radiation bakes the crust into a cracked, sterile wasteland where liquid water is instantly boiled into thin, escaping vapor. Conversely, the permanent night side is plunged into an eternal deep freeze, a desolate realm of solid ice where the atmosphere itself can snow down onto the dark, frozen ground. Between these two hostile extremes lies a narrow twilight ribbon known as the Terminator Line, offering a sliver of perpetual sunset and mild, stabilizing temperatures. This twilight zone represents a precarious sanctuary where liquid oceans might pool and gentle. Habitable climates could stubbornly persist against the odds. However, this delicate oasis is constantly battered by ferocious planet-wide winds that howl from the boiling day side toward the freezing night side in a desperate attempt to equalize the extreme temperatures. Any life clinging to this eternal sunset would exist in a state of constant twilight, forever watching a sun that refuses to rise or set, trapped halfway between fire and ice. Unlike those planets locked to a single, domineering star, circumbinary planets experience breathtaking sunrises where two stars slowly crest the horizon together in a cosmic waltz. These rare worlds orbit not just one, but a pair of central suns that actively twirl around each other in the very center of the system. The complex overlapping gravitational fields of the two stars create a deeply chaotic and shifting orbital path for any planet brave enough to encircle them both. If we were to stand on the rocky surface of such a world, we would witness shadows that constantly split, merge, and change their stark geometry throughout the day. The amount of solar energy reaching the ground fluctuates wildly as the two stars eclipse one another, plunging the planet into sudden unexpected chills or bathing it in compounding, scorching heat. Seasons on a circumbinary planet would be incredibly unpredictable, governed entirely by the shifting distances and the chaotic mechanical ballet of the twin furnaces in the sky. To survive the gravitational instability, these worlds must maintain a very wide, respectful distance from the central binary pair, often placing them far out into the freezing reaches of the system. Yet, if the combined heat of the two stars is powerful enough, this distant orbit might just provide the perfect, temperate conditions necessary for an atmosphere to flourish. The inhabitants of this world would live beneath a sky of profound beauty, their days measured by the endless chasing of two vibrant, differently coloured suns across the alien heavens. Deep in the dim, freezing outskirts of the planetary system, massive ice giants hide churning mantles of pressurised water and volatile ammonia beneath their cold, featureless clouds. Unlike the larger gas giants that are composed almost entirely of light hydrogen, these heavy, sluggish worlds are built around incredibly dense, rocky cores smothered by thick layers of exotic, slushy ices. Their atmospheres are hazy, freezing envelopes laced with atmospheric methane, which absorbs red light and reflects back a soothing, deep oceanic blue into the void. Beneath the visible cloud deck, the internal pressure and temperature spike dramatically, crushing the exotic ices into a bizarre supersonic state that behaves simultaneously like a solid and a liquid. Within this dark, churning mantle, carbon atoms are squeezed so tightly by the immense pressure that they crystallize, slowly raining millions of microscopic diamonds down toward the planet's hidden core. This slow, sinking rain of precious gems generates a tremendous amount of internal frictional heat, driving violent supersonic storms that visibly scar the planet's upper atmosphere. Let your breathing fall into a slow, steady rhythm, mirroring the quiet, ancient rotation of these massive blue titans slumbering in the dark. Their magnetic fields are often violently tilted and completely offset from their rotational axes, creating chaotic, swirling magnetospheres that eagerly trap the sparse, freezing solar wind. They remain solitary, frozen sentinels guarding the deep edges of the solar system, keeping watch over the vast, empty territories where the warmth of the sun is nothing more than a faint distant star. Just beyond the warm, rocky inner worlds, an asteroid belt provides a chaotic boundary line separating the terrestrial spheres from the freezing dominion of the gas giants. This vast, dispersed ring of rubble is not the remnants of a shattered planet, but rather a tragic collection of primordial building blocks that were never allowed to finish forming. The immense sweeping gravitational tides of nearby giant planets constantly stirred this rocky debris, violently accelerating the planetesimals and preventing them from gently coalescing into a single, cohesive world. Instead of a bustling planetary surface, this region is a sparse, lonely junkyard of shattered rock, gleaming metallic cores, and dusty, carbon-rich boulders. Collisions in this zone are incredibly rare due to the vast empty distances between individual asteroids, but when they do occur, they are catastrophic, high-speed impacts that instantly vaporize solid stone. The shattered fragments from these ancient collisions are occasionally flung inward toward the central star, becoming the very meteorites that streak across the night skies of the inner planets. Surprisingly, despite the immense volume of space it occupies, the total combined mass of an entire asteroid belt is often less than that of our own fragile solitary moon. It is a ghostly, scattered cemetery of potential, forever trapped in a state of arrested development by the domineering physics of the outer solar system. Mining these drifting metallic mountains may one day provide the vital, raw resources needed for advanced civilizations to push their architecture deeper into the starry void. At the very absolute fringes of the sun's gravitational reach, distant Oort clouds wrap solar systems in a fragile, icy shell of dormant, deeply frozen comets. This spherical reservoir of ancient, pristine debris extends halfway to the nearest neighbouring star, forming the ultimate invisible border between the local solar system and the deep interstellar wilderness. Out here, the central star is barely brighter than any other point of light in the sky, offering absolutely no warmth to the trillions of icy bodies hovering in the absolute dark. The objects trapped in this distant shell are the perfectly preserved frozen leftovers of the original protoplanetary disk, exiled to the freezing void billions of years ago. They drift in a state of suspended animation, moving at incredibly sluggish speeds through a region of space so expansive that their quiet orbits take millions of years to complete. Occasionally, the gentle, sweeping gravitational nudge of a passing rogue star or the subtle tidal shifts of the galaxy itself will disturb this delicate frozen equilibrium. When nudged from their slumber, these dormant comets begin a terrifying, agonizingly slow plunge inward toward the searing heat of the inner solar system. As they approach the sun, their frozen bodies violently sublimate, erupting into brilliant glowing tails of vaporized water and organic dust that stretch for millions of miles. These beautiful, fleeting celestial visitors carry the raw, untainted chemical memories of the stellar nursery, delivering ancient water and the very seeds of life to the warm, waiting worlds below. As these ancient seeds of life arrive on warm, waiting worlds below, they bring with them the most profound chemical secrets of the cosmos. Encased within the charred, blackened crusts of fallen meteorites, delicate amino acids have been discovered resting quietly inside their cold, rocky hearts. These spacefaring stones act as perfect cosmic vaults, shielding their fragile organic cargo from the incinerating heat of atmospheric entry. Deep within these primordial fragments, scientists have identified dozens of complex amino acids that are completely alien to our own terrestrial biology. The molecules exist in equal mixtures of left-handed and right-handed orientations, a chaotic chemical signature proving they were forged in the freezing void rather than on a living, breathing planet. They sit silently in the microscopic pores of the stone, completely untouched since the very dawn of the solar system. Allow your muscles to soften, feeling the heavy, comforting pull of the earth beneath you as you ponder these ancient wandering stones. It is a staggering realization that the exact chemical alphabet required to spell out the complex proteins of your own body was already written in the stars. Life's foundational ingredients were simply waiting in the dark, packed tightly inside wandering rocks long before the first oceans ever formed. Drifting far beyond the reach of these falling stones, vast molecular clouds in deep space contain the raw ingredients to brew cosmic alcohol on an incomprehensible scale. These sprawling interstellar nebulas are laced with trace organics that, if heavily concentrated, would carry the faint, distinct scent of bitter almonds and sweet burning sugar. They are the ultimate boundless chemical laboratories of the galaxy, operating in a slow, freezing silence over eons. Within these ethereal structures, simple atoms of carbon, hydrogen, and oxygen are constantly colliding in the incredibly sparse, cold vacuum. Over millions of years, these exceptionally rare encounters slowly build up monumental quantities of methanol, ethanol, and complex sugars drifting freely among the stars. The sheer volume of alcohol contained within a single molecular cloud could easily surpass the entire mass of thousands of terrestrial planets. If we were to look closely at the center of our own galaxy, we would find a massive cloud composed almost entirely of this floating, intoxicating vapor. The presence of these organic compounds proves that the universe is not a sterile, dead expanse of empty, hostile radiation. Instead, the dark spaces between the stars are actively churning with the sweet, sticky precursors necessary to eventually ignite biology. Surprisingly, the primary catalyst for this vast interstellar brewery relies entirely on microscopic particles of dust coated in unimaginably thin layers of frost. Imagine tiny, free-floating ice grains acting as dedicated chemical factories when unexpectedly struck by the faint wandering light of distant stars. In the extreme cold of deep space, volatile gases freeze instantly onto these specks of silicate, creating a fragile mantle of frozen chemical potential. When a stray, high-energy ultraviolet photon from a newborn star pierces the dark cloud, it aggressively strikes the frozen mantle of the dust grain. This sudden infusion of cosmic energy shatters the simple molecular bonds of the frozen water and carbon monoxide trapped tightly on the surface. The fragmented atoms are then completely free to recombine in wildly new, complex configurations before instantly freezing back into place. This microscopic cycle of shattering and freezing allows incredibly complex organic molecules to slowly accumulate on the invisible dust over billions of years. The surface of the ice grain provides a vital, solid meeting ground where scattered atoms can finally find one another in the endless void. Without these tiny, frozen anvils to hold the reacting elements steady, the complex chemistry of life would simply be impossible in the vacuum of space. This sprawling chemical ingenuity is largely driven by the unparalleled flexibility of carbon, the undisputed backbone of all known biological architecture. In the harsh, irradiated environments of the interstellar void, carbon atoms link together to form incredibly resilient microscopic rings known as fullerenes. These elegant, cage-like structures resemble infinitesimally small soccer balls, tightly bound and nearly impervious to the destructive forces of deep space. Unlike fragile chains of molecules that can be easily snapped by violent ultraviolet radiation, these geometric spheres distribute the incoming energy across their entire surface. They can absorb massive blistering hits from cosmic rays and simply vibrate, rapidly shedding the excess heat without breaking their intricate atomic bonds. This astonishing durability allows carbon to survive the perilous, endless journey across the galaxy without being reduced back to its basic elemental state. Take a slow, deep breath, expanding your chest as you imagine these indestructible, invisible cages floating silently through the cosmic winds. These geometric marvels often trap other rarer atoms inside their hollow cores, safely transporting them across the deadly expanse of the universe like microscopic armoured ships. They represent nature's ultimate shielding mechanism, ensuring that the vital, complex chemistry of carbon is preserved no matter how violent the surrounding cosmos becomes. While wandering dust carries these durable molecules through the void, it is the plunging comets that actively deliver pristine packages of frozen organics to the surfaces of volatile planets. We know these icy bodies carry essential water, but their true biological value lies deep within their porous, dirty interiors, far shielded from the searing heat of the sun. The core of a comet is a deeply compacted snowball of pristine interstellar chemistry, preserved at absolute zero since the chaotic dawn of time. When these colossal, icy messengers finally collide with the terrestrial world, the sheer kinetic violence of the impact would seem certain to obliterate their fragile chemical cargo. However, the rapidly melting exterior acts as a sudden, massive shock absorber, safely cushioning the deepest layers of the cometary heart from total destruction. Deep within the fracturing ice, complex hydrocarbons and delicate organic rings survive the apocalyptic crash entirely intact and ready to mingle with the alien soil. This violent delivery mechanism effectively injects a massive, concentrated dose of the universe's finest prebiotic chemistry directly into the sterile, cooling crust of a newborn planet. The resulting impact craters immediately fill with pooling, nutrient-rich meltwater, creating warm, temporary lakes perfectly primed for further rapid chemical evolution. The destructive fury of the comet strike is precisely the necessary force that allows the fragile seeds of life to be planted deep into the ground. Even with these universal organics successfully delivered, the ultimate blueprint of life fundamentally requires an incredibly specific, rare element to bind its genetic code together. Phosphorus, a crucial, non-negotiable component for the backbone of cellular energy, is forged exclusively in the explosive death of massive dying stars. Unlike the abundant carbon or oxygen created steadily during a star's normal burning life, this elusive element strictly demands a catastrophic, blinding finale. In the absolute final, desperate fractions of a second before a hypermassive star collapses inward, the internal pressure spikes to an anomalous, shattering degree. It is only within this fleeting, apocalyptic window of extreme nuclear fusion that stable atoms of phosphorus are violently fused into permanent existence. Moments later, the star detonates in a terrifying supernova, permanently embedding this precious, newly minted element into the expanding, superheated shockwave. Because it is born only in the rarest, most violent stellar deaths, phosphorus is incredibly scarce compared to the other primary building blocks of life. Its extreme rarity dictates that the universe must carefully ration the very glue that holds genetic information together, scattering it thinly across the galactic dust. The twisting, elegant double helix of your own cellular architecture relies entirely on this scarce, explosive stardust to maintain its vital, living structure. Alongside this rare, vital phosphorus, the expanding shockwaves from dying stars also push massive, billowing clouds of polycyclic aromatic hydrocarbons through the galaxy. These complex carbon-rich molecules float through the interstellar medium, resembling the thick microscopic soot from a universal, ever-burning chimney. They are astonishingly abundant, permeating nearly every dark corner of the cosmos, and visibly dimming the background starlight of entire sweeping galaxies. Picture these sprawling web-like molecular structures actively soaking up the fierce, damaging ultraviolet radiation emitted by young, aggressively burning suns. As they absorb this lethal energy, the molecules become highly excited, violently vibrating before slowly releasing the energy back into the void as harmless, gentle infrared heat. In this incredible way, the cosmic soot acts as an invisible, protective sunscreen for the entire galaxy, shielding more delicate chemical reactions from the searing stellar glare. Let your mind rest on the quiet, dark spaces between the stars, knowing they are filled with this drifting, highly protective organic smog. Without this ubiquitous soot absorbing the harshest cosmic rays, the fragile, newly formed amino acids would be instantly sterilized by the ambient radiation. This dirty, carbon-laced haze is not a mere pollutant of the cosmos, but a necessary sheltering canopy under which the fragile sparks of life can safely ignite. Once these universal, protected organics safely reach the chaotic atmosphere of a young Earth, entirely new, ferocious energy sources begin to aggressively manipulate them. Relentless, violent lightning strikes rippling across early, toxic skies may have actively shocked simple atmospheric gases into much more complex prebiotic organics. The skies of our primordial world were not a calming blue, but a choking, hazy mixture of methane, ammonia, and water vapor, churning in perpetual dark storms. When a massive electrical discharge tore through this highly volatile atmosphere, it generated immense localized flashes of heat that instantly shattered the stable bonds of the hovering gases. As the superheated air rapidly cooled in the fraction of a second following the strike, the isolated atoms desperately scrambled to recombine into new, stable forms. This sudden, severe electrical trauma forced the simple elements into entirely different, heavier configurations, raining a steady shower of complex hydrocarbons down into the turbulent seas. The sheer, unending frequency of these planetary storms meant that millions of lightning bolts hammered the primordial oceans every single day for eons. The deafening electrical fury of the early sky was not a destructive force, but an unrelenting planet-wide chemistry experiment operating on a staggering global scale. The raw, terrifying power of the tempest was actively forging the very molecules that would eventually learn to replicate, metabolize, and aggressively grow. Far below the chaotic, storm-tossed surface of these ancient oceans, a much quieter, slower chemical revolution was unfolding in absolute crushing darkness. Hydrothermal vents deep underwater combine the intense geothermal heat of the planet's rocky mantle with rich, dissolved minerals to spark a profoundly different type of prebiotic chemistry. These towering chimney-like structures exhale boiling, highly caustic fluids directly into the freezing, pressurized depths of the silent abyssal plain. Within the microscopic, highly porous walls of these rocky chimneys, an incredible natural gradient of extreme temperature and chemical acidity is perfectly established. Iron and sulfur compounds erupting from the vent act as powerful chemical catalysts, eagerly grabbing hold of the raw carbon and hydrogen dissolved in the surrounding seawater. The steady, highly reliable energy provided by the planet's internal heat slowly drives these basic floating molecules to fuse into self-sustaining, continuous metabolic loops. Unlike the violent sudden shocks of lightning at the surface, this deep-sea chemistry is a remarkably slow, patient, and infinitely stable evolutionary process. The microscopic rock chambers of the vent provide a safe, isolated haven where fragile chemical pathways can concentrate and evolve without being swept away by the churning ocean currents. It is precisely here, in the scalding, pitch-black depths, that the chaotic chemistry of the universe may have finally organized itself into the very first primitive pulse of life. When we pull back to view the grand, sweeping tapestry of this continuous chemical evolution, a staggering and incredibly beautiful truth is finally revealed. The essential building blocks of life are not miraculous, impossible anomalies, but rather the incredibly common dust scattered endlessly across the howling cosmic wind. The universe is practically overflowing with the exact ingredients required to construct complex biological organisms, brewing them constantly in the freezing, silent dark. From the highly resilient carbon rings drifting in the void to the fragile amino acids packed tightly inside falling stones, the cosmos is deeply, inherently organic. The very same fundamental reactions that occur in the darkest molecular clouds are identical to the invisible chemical processes happening within the warm living cells of your own body. We are not a bizarre accidental exception to the strict rules of the universe, but rather the inevitable, incredibly complex expression of its most basic, ubiquitous chemistry. As you sit quietly, feeling the steady, reliable, rhythmic beating of your own heart, recognize that you are entirely composed of this very same universal dust. The faint scent of bitter almonds and sweet sugar drifting through the void is the distant chemical memory of our own shared majestic stellar origins. Life is not an alien intruder in the cosmos. It is simply what the universe naturally does when given enough time, carbon, and a quiet, warm place to rest. While the universe provides many quiet places to rest, some life forms have mastered the art of waiting through the most hostile conditions imaginable. The microscopic tardigrade, a creature of staggering resilience, can survive the freezing, irradiated vacuum of outer space by entering a state of profound, suspended animation known as cryptobiosis. In this state, they expel nearly all the water from their bodies, shrinking into a dry, indestructible husk that can endure temperatures near absolute zero. When exposed to the airless void and the unfiltered glare of the sun, these tiny voyagers simply wait, their biological processes slowed to a near-total standstill. This ability to hit a cosmic pause button suggests that life might not need to actively thrive during a journey between worlds, but merely survive the passage. Once returned to a hospitable environment with a single drop of liquid water, the tardigrade miraculously rehydrates and continues its life as if the vacuum of space were nothing more than a brief, quiet nap. This suggests that the seeds of biology are far tougher than we once dared to dream, capable of crossing the celestial abyss. It is a comforting thought that life possesses such an inherent durability, allowing it to wait patiently for the right moment to awaken. In the subterranean silence of South African gold mines, miles beneath the sun-drenched surface, specialized bacteria thrive by eating the very radiation that would be lethal to most other life. These organisms, isolated for millions of years in water-filled fissures of ancient rock, have evolved to survive without any reliance on photosynthesis or the products of the surface world. Instead, they harness the energy released by the slow, natural decay of uranium and other radioactive minerals embedded in the surrounding stone. This process, known as radiolysis, splits water molecules into hydrogen, which the bacteria then use as a consistent fuel source to power their slow-motion metabolisms. Surprisingly, the universe has provided a way for life to persist in absolute darkness, decoupled from the energy of a parent star. These resilient microbes exist in a state of extreme patience, dividing perhaps only once every 1,000 years in their pressurized golden vaults. They remind us that the habitable zone of a solar system may extend far deeper into the rocky crust of a planet than we ever anticipated. This deep biosphere acts as a hidden reservoir of life, safely tucked away from the volatile changes of the surface world. It is a silent kingdom that proves life does not always need a sky to survive. This structure of biological persistence is perhaps most famously embodied by a microbe aptly nicknamed Conan the bacterium for its nearly supernatural ability to withstand trauma. Deinococcus radiodurans can absorb doses of gamma radiation thousands of times higher than what would instantly kill a human being, yet it remains completely unfazed. While such high-energy rays normally shatter DNA into hundreds of useless fragments, this resilient organism has developed a rapid response repair system that functions with breathtaking precision. Conan the bacterium keeps multiple copies of its genetic code tightly coiled in a ring, allowing it to use the intact segments as templates to reassemble its shattered genome in a matter of hours. A specialized suite of protective proteins guards its vital enzymes from oxidative damage, even while its DNA is being bombarded. This incredible mechanism ensures that even in the most irradiated environments, such as the surface of a moon or the interior of a spacecraft, the blueprint of life remains legible. It proves that biology possesses an inherent aggressive drive to maintain its integrity against the entropic forces of a violent universe. The very architecture of its being is designed to heal and persist through the most punishing cosmic storms. This internal guardian ensures that the message of life is never lost to the noise of background radiation. Surprisingly, the most hostile-looking environments on our own planet, like the boiling neon-coloured hot springs of volcanic regions, are actually vibrant theatres of microscopic activity. Within these churning acidic pools, specialised microbes known as acidophiles swim comfortably in fluids corrosive enough to dissolve human flesh within minutes. They have adapted to thrive in pH levels similar to concentrated battery acid, maintaining a neutral internal environment by actively pumping out excess protons as fast as they enter. Notice how your own breathing is effortless and steady, a sharp contrast to the high-energy struggle of these microbes as they maintain their delicate internal balance. Their cell membranes are reinforced with specialised fats that act as a chemical armour, preventing the surrounding acid from tearing their molecular structures apart. These vibrant, steaming landscapes, often painted in shades of electric orange and brilliant green, serve as terrestrial models for the caustic environments we might find on young volcanic exoplanets. Life here does not just endure the corrosion, it embraces it, utilising the intense chemical gradients to power its existence in a landscape that appears, to our eyes, like a beautiful but deadly alien world. It is a vivid reminder that what we define as a sterile wasteland might actually be a lush, thriving home for the resilient. These colourful pools are the fingerprints of an ancient, boiling vitality. Far beneath the massive, unyielding weight of the Antarctic ice sheet, a secret ecosystem thrives in total darkness and sub-zero temperatures. At a site known as Blood Falls, a briny, iron-rich liquid occasionally seeps from the base of a glacier, staining the pristine white snow a startling, rusty crimson. This flow originates from a subterranean lake that has been sealed away from the atmosphere and sunlight for over 2 million years. Within this cold, pressurized tomb, a unique community of microbes has learned to survive by metabolizing sulfur and iron compounds, harvested from the underlying bedrock. They exist in a world where time seems to have frozen, slowly processing minerals in a chemical cycle that requires no oxygen and no warmth. This isolated biosphere demonstrates that life can find a way to persist in the most extreme planetary refrigerators, surviving on the scraps of geological energy. Such environments are remarkably similar to the hidden oceans of icy moons like Europa, suggesting that the dark, frozen depths of our solar system may not be as empty as they appear. The persistence of these cold-dwelling microbes expands our search for life to the furthest, darkest corners of the planetary neighbourhood. It shows that even in the absolute zero of isolation, the fire of metabolism can still burn. If we were to look closer at the edges of the sea or within salt-crusted deserts, we would encounter the stunning artistic impact of halophils on the landscape. These salt-loving organisms paint evaporation ponds and hypersaline lakes a soothing, vivid shade of flamingo pink or deep violet. To survive in water 5 times saltier than the ocean, they have evolved a specialized light-harvesting protein called bacteriorhodopsin, which is structurally similar to the pigment in the human eye. This protein allows them to convert sunlight directly into chemical energy without the need for complex chlorophyll, acting as a primitive but highly efficient solar panel. As you rest here, perhaps sensing the subtle saltiness of your own skin, consider these tiny organisms thriving in conditions that would dehydrate and shrivel almost any other living cell. They maintain their internal pressure by accumulating high concentrations of potassium, effectively fighting salt with salt to stay hydrated. These vibrant, colourful blooms are so expansive they can be seen from space, serving as a bright biological signal of resilience in the harshest, driest corners of our world. They prove that life can turn a chemical challenge into a source of brilliant, radiant power. The landscape itself becomes a living canvas of salt and sunlight. This endurance takes on a nearly eternal quality when halophales become trapped inside the microscopic fluid inclusions of ancient salt crystals. Within these tiny subterranean time capsules, microbes have been found in a state of deep metabolic slumber that has lasted for over 1 million years. They're not dead, but rather suspended in a microscopic bubble of brine, waiting for the moment when the crystal might dissolve and release them back into the world. When scientists carefully extract these ancient survivors and provide them with fresh nutrients, the microbes often wake up and begin to divide as if no time had passed at all. This incredible feat of longevity suggests that the fundamental spark of life is remarkably difficult to extinguish once it is safely shielded from the environment. Feel the weight of your own history and the long line of life that led to your present moment of quiet relaxation. These crystalline voyages prove that life can act as its own biological archive, crossing vast epochs of geological time to bridge the gap between ancient worlds and the present day. They are silent witnesses carrying the genetic memories of a distant past into the modern age. Time itself seems to bend around these resilient, salty travellers. Beneath the crushing pressures of the deep ocean, where volcanic vents erupt with superheated fluid, specialised thermophils flourish in water heated far past the normal boiling point. Because of the immense weight of the miles-thick ocean above, the water at these depths can reach temperatures of over 300 degrees Celsius without ever turning into steam. Hyperthermophilic microbes cluster around these chimneys, thriving in a narrow ring of warmth where the water is a staggering 121 degrees. Their proteins and enzymes are uniquely reinforced with extramolecular bonds that prevent them from denaturing or melting in the intense heat. This extreme environment is likely very similar to the conditions found on the early Earth, suggesting that our most distant ancestors may have been born in the scalding heat of the abyss. For these organisms, the freezing temperatures of the rest of the ocean are a lethal, uninhabitable wasteland. They represent a version of life that finds its comfort in the fire, proving that the definition of a habitable environment is entirely dependent on the perspective of the inhabitant. In the boiling dark, they build a world that is as stable and reliable as any forest on the surface. These vents are the glowing heartbeats of the deep, dark sea. Extraordinarily, life can even turn a site of technological disaster into a source of nourishment, as seen with the fungi discovered inside the ruins of the Chernobyl reactor. These specialized molds do not merely survive the lethal levels of radiation, they actively grow toward the most radioactive areas and feed on the high-energy particles. They utilize a dark pigment called melanin, the same substance that protects human skin from the sun, to capture gamma radiation and convert it into chemical energy for growth. This process, known as radiotrophism, allows the fungi to colonize environments that would be instantly fatal to almost any other organism on the planet. Instead of being destroyed by the invisible rain of subatomic particles, they use it as a consistent and reliable power source. This adaptation reveals a stunning evolutionary flexibility, where life takes a force of pure destruction and transforms it into a life-sustaining meal. It suggests that on worlds where cosmic radiation is intense, such as the surface of Mars or Europa, life might evolve to embrace the energy of the void rather than hide from it. This fungal persistence turns our greatest fears of contamination into a blueprint for cosmic survival. The ruins themselves have become a nursery for a new kind of biological strength. Finally, the most pervasive but hidden form of life on our planet may be the endoliths, organisms that live their entire slow-motion lives hidden inside the microscopic pores of solid rock. These stony inhabitants have been discovered miles deep within the Earth's crust, dwelling in the tiny cracks of granite and basalt. They do not hunt or move in the way we understand, but instead slowly graze on the trace minerals and gases that seep through the stone. As you sink deeper into your own state of rest, imagine this vast, silent kingdom of stone, where life measures its progress in geological epochs rather than seconds. They are the ultimate proof that the universe can find a home for life, not just on a planet, but deep within its very bones. This deep hidden pulse is the foundational heartbeat of our living world. Deep within the Jovian system, a foundational heartbeat pulses beneath the frozen exterior of Europa, a moon that hides a massive saltwater ocean beneath its cracked and scarred surface. This dark global sea is estimated to contain more than twice the volume of all Earth's oceans combined, held in a liquid state by the constant gravitational kneading of Jupiter. The surface is a chaotic mosaic of reddish-brown lines and ridges, suggesting that the ice shell is constantly fractured by the churning pressure of the abyss below. If we were to look closer at these icy fractures, we would see evidence of mineral-rich water welling up from the depths and freezing into the scars of the crust. This hidden world remains shielded from the lethal radiation of Jupiter's magnetosphere by a shell of ice that may be many miles thick. It is a place of absolute darkness, yet it represents one of the most promising sanctuaries for life in the entire solar system. The muffled, deep-frequency groaning of the ice shifting overhead is the only sound in this vast, submerged cathedral. Each rhythmic groan echoes the internal pressure of a world that is straining to breathe beneath its frozen mask. The reddish salts that stain the surface fractures are likely the very chemicals needed to sustain a complex biological ecosystem in the lightless deep. This structure of hidden vitality is even more visible on Saturn's tiny moon Enceladus, which shoots towering geysers of water vapour and organic material straight into the freezing silence of outer space. These majestic plumes erupt from deep parallel fractures at the moon's south pole, known as tiger stripes, which act as direct conduits to a pressurized subsurface sea. As the moon orbits Saturn, the planet's immense gravity pulls and stretches the rocky core, generating the friction needed to keep the water liquid. Analysis of these celestial fountains reveals a complex chemical cocktail of salts, silicates, and large organic molecules, suggesting that the ocean floor is geologically active. Surprisingly, the presence of molecular hydrogen in the plumes points toward the existence of hydrothermal vents on the seafloor, mirroring the life-sustaining chimneys found in Earth's deep oceans. These geysers effectively offer a free sample of an alien ocean, allowing us to study the chemistry of a hidden world without ever needing to touch its surface. The spray of fine ice crystals creates a shimmering, translucent veil that hangs over the moon like a ghostly crown. In this frozen mist, we find the unmistakable fingerprints of an environment that is warm, wet, and chemically rich. It is as if the moon is offering its most intimate secrets to anyone willing to watch the light catch its breath. Deep within the hazy orange shroud of Titan, a world famous for its methane lakes, a much deeper and more mysterious reservoir of water resides far below the hydrocarbon crust. While the surface is a frigid landscape of organic dunes and liquid gas, the moon's interior hides a pressurized, warm ocean where exotic chemistry might thrive in total darkness. This deep, aqueous realm sits atop a rocky seafloor, potentially allowing for the same mineral-rich interactions that spark biology on terrestrial worlds. Imagine the warm, rocky seafloor of Titan, where the absence of sunlight is compensated by the steady, internal heat of the moon's decaying core. Here, life could take on forms entirely alien to our experience, utilizing chemical pathways that bypass the need for photosynthesis. As you sink into your own state of rest, feeling the soft, heavy rhythm of your breathing, consider the silent, submerged plains of this distant moon. The interaction between the liquid water and the rocky interior creates a chemical gradient that acts as a slow-burning battery for potential life. This hidden sea remains one of the final frontiers in our understanding of how varied the architecture of a habitable world can truly be. Even beneath a sky of orange smog, a liquid world of profound potential waits for its moment of discovery. Surprisingly, the largest moon in the solar system, Ganymede, possesses its own intrinsic magnetic field, a rare feature that helps shield its deeply buried liquid water from the harsh Jovian environment. This magnetic envelope acts as a protective bubble, deflecting the rain of high-energy particles that would otherwise strip away the moon's fragile atmosphere. Beneath several layers of ice and rock, a vast saltwater ocean is potentially sandwiched between different phases of high-pressure ice, creating a unique, multi-layered liquid environment. This magnetic shield is generated by the churning of a liquid iron core, proving that even a moon can maintain the internal machinery of a planet. Notice how the presence of aurorae on Ganymede, shifting in response to Jupiter's influence, provides the subtle clue that an electrically conductive ocean must be lurking far underground. Take a moment to feel the stillness of your own body, safe and protected, just as this hidden sea is cradled within its magnetic and icy vault. The scale of this submerged world is staggering, potentially containing multiple oceans stacked like a cosmic cake in a quiet, powerful testament to the complexity hidden within the hearts of giant planets. This world is a giant among satellites, a layered fortress of ice and salt that defies our simplest definitions of a moon. Moving closer to the Sun, the dwarf planet Ceres reveals a muddy, brine-filled interior that is slowly freezing over time, leaving behind magnificent evidence of its liquid past. Large, bright deposits of sodium carbonate on its surface suggest that salty water once surged upward from a subsurface reservoir, evaporating to leave these shimmering mineral scars. The existence of a Huna Mons, a towering cryovolcano, proves that the interior was once warm enough to erupt with a viscous slurry of ice and salt. These eruptions are not fueled by molten rock, but by the freezing and expansion of subterranean brines, a process that mimics the volcanic activity of terrestrial planets. The interior of Ceres remains a transition world, a bridge between the rocky inner system and the icy moons of the outer giants. If we were to look closer at the crater floors, we would see the faint white remnants of a world that is still geologically exhaling. This dwarf planet serves as a reminder that the ingredients for a watery interior were present even in the asteroid belt as a silent, cooling relic of the early solar system's damp childhood. Its bright spots are like the glittering memories of a sea that has since retreated into the dark, stony heart of the planetoid. The primary engine driving this hidden vitality is the relentless force of tidal friction generated by the massive gas giants, which creates the internal heat necessary to melt these alien oceans. As a moon travels along its slightly elliptical orbit, the immense gravitational pull of its parent planet varies, causing the moon's solid body to stretch and compress. This rhythmic internal kneading generates a tremendous amount of heat through friction, much like the warmth created when you repeatedly bend a piece of metal back and forth. This gravitational dance ensures that even worlds located far beyond the Sun's traditional habitable zone can maintain liquid water for billions of years. Without this tidal squeezing, these moons would be frozen solid to their cores, sterile and unchanging in the cosmic dark. The energy does not come from the Sun, but from the mechanical architecture of the solar system itself, proving that life can be powered by the very geometry of gravity. Notice the steady, effortless weight of your own form, a quiet parallel to the heavy invisible hands of gravity that shape the destinies of these distant worlds. This unseen force turns the freezing outer reaches into a landscape of potential warmth, transforming a graveyard of ice into a cradle of liquid seas. Gravity is the silent fire that keeps the hearts of these distant worlds beating against the cold. This structure of erupting water does more than just hint at hidden life. The plumes from Saturn's moons actively feed the planet's breathtaking and expansive ring system. Specifically, the tiny moon Enceladus is the primary architect of the E-ring, a vast and diffuse halo of ice crystals that orbits far beyond the main, brilliant bands. Most of the material ejected from the southern geysers escapes the moon's weak gravity, entering a direct orbit around the gas giant to create a shimmering, ethereal donut of ice. In contrast to the fractured and young surfaces of its neighbours, the ice shell of Callisto is incredibly ancient and heavily cratered, hiding its own quiet ocean deep within. As the most heavily cratered object in the solar system, its surface has remained largely unchanged for billions of years, preserving a record of every impact since the early days of the Sun. Beneath this battered, unmoving crust lies a dark sea that is insulated from the surface by nearly 100 miles of solid rock and ice. Because Callisto is further from Jupiter, it experiences less tidal heating, allowing its ocean to remain in a state of tranquil, undisturbed balance. The depth of this sea makes it one of the most stable environments in the outer solar system, a place where time seems to have no meaning. Feel the profound stillness of the room around you, mirroring the eternal, unruffled calm of Callisto's buried waters. This moon serves as a baseline for the outer system, a world that has kept its secrets locked away in a vault of ancient, pockmarked ice. It is a testament to the fact that even the most seemingly dead and battered surfaces can conceal a heart of liquid potential. While its siblings are torn by tidal storms, Callisto remains a silent, stoic witness to the history of the solar system. At the edge of the major planetary system, Neptune's largest moon, Triton, orbits the planet backward while venting dark plumes of nitrogen gas from its frigid crust. This retrograde motion suggests that Triton was once a rogue traveller from the Kuiper Belt, captured by Neptune's gravity in a violent event that likely melted the moon's entire interior. The heat from that ancient capture, combined with the decay of radioactive elements, may still maintain a liquid layer deep beneath its surface of nitrogen and water ice. The plumes observed on Triton are a form of solar-powered cryovolcanism, where sunlight penetrates the clear ice and heats dark deposits of organic material below. This trapped heat causes the nitrogen ice to sublimate and erupt in towering geysers that can reach miles into the thin, freezing atmosphere. These dark streaks of soot-like material drift across the pale, pinkish terrain, marking the surface with the evidence of a restless interior. Triton is a world of extreme contradictions, a captured wanderer that maintains a faint geological breath despite being one of the coldest places in the solar system. It represents the ultimate outpost of liquid potential before the true deep freeze of the interstellar void. The dark plumes are like smoke from a dying fire, signalling that even at the edge of the sun's reach, a world can still stir. To finally touch these hidden seas, future submarines designed for alien oceans must be able to melt through miles of unyielding ice just to splash down into the abyss. These robotic explorers, known as cryobots, would utilize a small nuclear heat source to slowly liquefy a path through the frozen shell, descending into the dark like a hot needle through wax. The journey through the ice could take many months or even years, requiring the probe to operate in total isolation as it maneuvers around buried rocks and pockets of salt. Once they breach the final barrier, these submersibles would deploy sensors to search for the chemical signatures of life around hydrothermal vents on the seafloor. They would have to withstand pressures far greater than those found in Earth's deepest trenches, navigating a world where the only light comes from the faint bioluminescent glow of the probe itself. Imagine the moment of transition, when the muffled, deep-frequency groaning of the shifting ice finally gives way to the silent, weightless embrace of an alien sea. As you rest in the comfort of your own space, consider the ingenuity required to reach across the void and dive into the unknown. This technology represents our first true attempt to swim in a sea that was born under the light of a different sky, turning our curiosity into a bridge across the frozen deep. Beyond the bridge across the frozen deep, the journey leads us to the hazy amber shroud of a moon that mimics the early chemistry of our own world. Titan features a dense golden atmosphere where the air is so thick and the gravity so low that a human could fly by simply strapping wings to their arms. This nitrogen-rich sky is perpetually choked with a smog of complex organic molecules called tholins, which rain down to coat the surface in a sticky, soot-like grime. In this surreal environment, the temperature is so incredibly low that water ice becomes as hard as granite, while methane behaves exactly like water does on Earth. Imagine standing on a shoreline where liquid methane rains from the sky to fill vast, dark hydrocarbon lakes that ripple under a gentle, cold breeze. This alien weather cycle creates a landscape of carved riverbeds and sprawling seas, offering a chillingly beautiful mirror to our own planet's hydrological processes. As you sit in the quiet of your room, let your mind drift to these distant, oily shores where the sky's a permanent ceiling of glowing orange mist. The scent of this world would be heavy and metallic, a sharp contrast to the crisp air we breathe, yet it holds the fundamental ingredients that once stirred in Earth's primordial soup. This golden vault remains a sanctuary of prebiotic potential, protected from the harshness of the outer solar system by its own thick chemical breath. If we were to look closer at the inner reaches of our solar system, we would find a haunting cautionary tale written in the suffocating clouds of our sister world. Venus was once a temperate water world, likely possessing vast oceans and a climate that could have cradled the first sparks of life. However, as the sun gradually brightened over billions of years, the planet's surface warmed until its oceans began to evaporate into the atmosphere. The resulting thick blanket of water vapor acted as a powerful trap for heat, triggering a catastrophic and runaway greenhouse effect that permanently altered the planet's destiny. Without liquid oceans to absorb carbon dioxide into the rocks, the gas built up until the atmosphere became a crushing, superheated furnace. Today, the surface is a desolate wasteland of volcanic plains, where the pressure is enough to flatten a lead submarine. The transition from a blue paradise to a hellish landscape of sulfuric acid clouds happened in a slow, agonizing geological instant. This structure of atmospheric collapse serves as a profound reminder of the delicate balance required to maintain a habitable home. It is a world where the air itself has become a lethal weight, a testament to how quickly a sanctuary can transform into a terminal prison under the gaze of a warming star. This structure of atmospheric fragility is equally evident on the rusting plains of the red planet, which now possesses only a ghostly remnant of its former self. Mars retains only a whisper of its former atmosphere, a thin veil of carbon dioxide that is far too sparse to trap heat or protect the surface from the cosmic void. In its youth, the planet was shielded by a global magnetic field that allowed for a thick sky, flowing rivers, and potentially a northern ocean. Surprisingly, the death of the planet's internal dynamo led to the loss of this magnetic shield, leaving the atmosphere vulnerable to the relentless solar winds. High-energy particles from the sun began to aggressively strip away the air, literally sandblasting the gas molecules out into the darkness of space over millions of years. This process of sputtering turned a once vibrant world into a freezing, hyper-arid desert, where the sky is now thin enough to see the stars during the day. Take a slow, deep breath and feel the richness of the air around you, a luxury that has been denied to the Martian surface for eons. The red planet stands as a skeleton of its past, its former oceans lost to the void, and its ancient skies reduced to a cold, dusty sigh. It is a world that has been exhaled into the vacuum, leaving behind only the dry, silent riverbeds, as a memory of what was once a sky full of rain. Surprisingly, the void between worlds is no longer a barrier to our sight, as we learn to read the chemical signatures of planets orbiting distant suns. Notice how the James Webb Space Telescope analyzes starlight filtering through exoplanet skies to detect the unmistakable fingerprints of water and carbon. As a planet passes in front of its star, a tiny fraction of that starlight passes through the outer layers of its atmosphere before reaching our mirrors. By breaking this filtered light into a rainbow of colours, scientists can identify exactly which molecules are absorbing the starlight based on the specific gaps in the spectrum. This technique of transmission spectroscopy allows us to peer across light years to witness the steam rising from water-world atmospheres or the presence of thick, methane-rich hazes. It is as if the universe is providing us with a cosmic flashlight to illuminate the hidden chemistry of alien heavens. As you rest your body and allow your eyes to gently close, imagine these beams of starlight travelling across the vastness of space to tell us a story of water and air. We are no longer limited to the planets we can visit. We are now catching the light of 1,000 different twilights. Every data point is a bridge between our curiosity and a world that might be exhaled by a biology we have yet to meet. Deep within the searing proximity of alien suns, the laws of weather are rewritten into a violent and dazzling display of mineral storms. Silicate snow falls sideways on scorching planets, plagued by supersonic, glass-shredding winds that move faster than the speed of sound. On these hot Jupiters, the temperatures are so extreme that rocks and metals do not stay solid. They vaporize and rise into the upper atmosphere to form clouds of liquid stone. When these clouds drift toward the cooler night side of the planet, the vaporized minerals condense into tiny, jagged grains of sand and glass that pelt the landscape in a horizontal fury. The sheer energy of the atmosphere creates a world where the rain is made of molten iron and the snow is composed of shimmering rubies and sapphires. This is an environment of terminal beauty, where the air itself is an abrasive and glowing torrent of metallic vapor. The winds on these worlds are driven by the massive temperature difference between the side perpetually facing the star and the side in eternal shadow. This creates a global jet stream that never rests, carrying the heat of a furnace into the cold of the abyss in a constant roaring cycle. It is a reminder that the heavens are not always peaceful. Sometimes they are the site of a geological storm that defies every earthly comparison. Therefore, the detection of oxygen in a distant sky usually requires life to be constantly and aggressively replenishing it through processes like photosynthesis. This gas is a biological signature, a loud chemical scream that indicates the presence of organisms churning through energy and exhaling waste into the heavens. If we were to look closer at Earth's history, we would see that our own sky was only transformed by the arrival of tiny sun-eating microbes that turned the atmosphere into a breathable sanctuary. Feel the gentle rise and fall of your chest, a rhythmic exchange that depends entirely on this reactive living gas. We are breathing the byproduct of a billion-year-old biological revolution that continues to this very day. Without the tireless work of every leaf and every microscopic plankton, the oxygen we depend on would simply rust away into the ground, leaving us in a silent and suffocating world. This structure of atmospheric dominance reaches its most gargantuan expression in the hearts of the giant planets that dwarf our own. Gas giants are almost entirely atmosphere, possessing no solid surface to walk upon and no clear boundary where the air ends and the ground begins. As you descend through the clouds of a world like Jupiter, the gas simply becomes denser and hotter until it behaves more like a liquid or a crushing metallic ocean. Within these vast envelopes of hydrogen and helium, storms can rage for hundreds of years, far outlasting the civilizations that observe them from afar. The Great Red Spot is a hurricane twice the size of Earth that has been spinning in a relentless crimson whirlpool for as long as we have had telescopes to see it. These worlds are the ultimate expressions of atmospheric power, where the weather is the only landscape that exists. Allow your muscles to sink deeper into the support of your chair, a luxury that would be impossible in the weightless, crushing depths of a giant sky. Out there, the only stability is found in the rhythmic rotation of the planet itself, a massive spinning top of gas and lightning. These titans are the guardians of the outer system, their atmospheres acting as massive vacuum cleaners that protect the inner worlds from wandering debris. A far more subtle and elusive signal may drift across the interstellar winds, carrying the scent of a thriving alien sea. Dimethyl sulfide is a gas produced almost exclusively by living organisms in Earth's oceans, primarily by microscopic phytoplankton as they go about their daily lives. On our world, this gas is the primary source of the smell of the sea, a pungent and earthy aroma that drifts inland with the salt spray. Because there are no known natural ways to produce this gas in large quantities without life, its detection in a distant atmosphere would be a monumental discovery. If we were to find a methyl sulfide in the sky of a water-covered exoplanet, it would strongly suggest that the alien oceans are not just wet, but populated by a complex metabolic biosphere. It is a microscopic message sent from the depths of an alien sea into the heights of its sky. This gas represents the connection between the hidden biology of the abyss and the visible chemistry of the heavens. It reminds us that even the smallest life forms can alter the composition of an entire planet's atmosphere, leaving a trace that can be seen across the stars. We are searching for the smell of home in the middle of a cosmic ocean, a faint and salty hope that we're not the only ones breathing. Picture an invisible parasol made of fragile molecules that stands between you and the incinerating fury of the stars. An ozone layer acts as a gentle, transparent shield, absorbing the most dangerous ultraviolet radiation before it can reach the surface and shatter the delicate bonds of DNA. This layer is a byproduct of oxygen, meaning that a planet must first be filled with life before it can create the very protection needed for life to move on to land. As you feel the warmth of the light around you, consider the silent work of the stratosphere in keeping that light from becoming a weapon. Every habitable world must likely develop its own version of this molecular shield to survive the long, slow burn of its parent star. It is a fragile gift, a thin blue line that holds the line against the infinite energetic anger of the cosmos. Shutterstock. Surprisingly, the most common stars in the galaxy present the most violent challenges for the atmospheres of the planets that orbit them. Planets orbiting red dwarfs are huddled so close to their small, cool suns that they are constantly bombarded by extreme solar flares that can be thousands of times more powerful than those of our Sun. To survive this onslaught, these worlds may need thick, permanent cloud covers to act as a secondary shield for the surface. These massive cloud decks would reflect the harshest radiation back into space, while helping to distribute the star's heat from the permanent day side to the eternal night side. If we were to observe such a world, we might see a planet that is entirely white or grey, its surface forever hidden beneath a roiling, protective blanket of steam and ice. Life on such a world would never see its sun, living instead in a world of perpetual diffused twilight and constant muffled thunder. In the heavy shadowed silence of worlds where thunder rolls beneath a permanent ceiling of clouds, we begin the hunt for the subtle, rhythmic green line of a spectrograph. This scientific instrument acts as a cosmic eye, translating the faint glimmers of distant light into a coded language of chemical presence. Deep within the data, we search for the red edge, a sharp and unmistakable change in the intensity of reflected light that serves as a beacon for vast plant life. On a living planet, vegetation has evolved to absorb visible light for energy, while aggressively reflecting infrared light to avoid overheating. This creates a dramatic cliff in the light spectrum that is virtually impossible for inanimate rocks or minerals to replicate. When we detect this sudden leap in brightness, we are witnessing the collective reflection of billions of alien leaves or alien fronds reaching toward their sun. This biological mirror is a testament to the planet's green or crimson vitality, a silent signal that life has successfully colonized the land. It suggests a world where the surface is no longer just stone and water, but a breathing photosynthetic carpet. As the spectrograph sweeps across the data, this sudden spike in the infrared becomes the first definitive fingerprint of a flourishing alien biosphere. Surprisingly, the very breath of a planet can be measured across the vastness of space through the seasonal variations in atmospheric methane. On a world where life is active, the concentration of this gas does not remain static, but instead rises and falls in a rhythmic, predictable cycle. This fluctuation is often a tantalizing clue that biological organisms are responding to the changing seasons, exhaling methane as they grow or during periods of decay. If we were to look closer at these cycles, we would see a global metabolism at work, a planet-wide inhalation and exhalation that matches the orbital dance of the seasons. While geological processes like serpentinization can produce methane, they rarely produce the sharp, rhythmic pulses associated with biological activity. These chemical tides suggest a world that is not just a stagnant rock, but a dynamic and living system. Notice how your own breathing has found a slow and steady rhythm as you contemplate the pulse of a distant world. Just as your lungs exchange gases with the air around you, an entire planet may be participating in a massive atmospheric dialogue with its inhabitants. This seasonal breathing is a hallmark of a biosphere that has taken control of its world's chemistry, turning the atmosphere into a record of its own life. Deep within the darkness of a planet's night side, we search for techno-signatures that reveal the presence of an advanced civilization. While the day side is dominated by the glare of the sun, the dark hemisphere offers a pristine canvas to look for the artificial glow of massive city lights. This light would not be the flickering orange of a forest fire or the dull red of a volcano, but the distinct, concentrated brilliance of organized technology. The spectral signature of these lights would be rich in specific colors that are rare in nature, such as the sharp peaks produced by sodium or mercury vapor lamps. To see a planet's night side illuminated by a web of light would be to witness the ultimate triumph of intelligence over the darkness. It would tell us that we are looking at a world where a society has harnessed the power of electricity to transform their environment. This artificial glow would serve as a technological beacon, a silent announcement of a world that is no longer quiet. It represents a civilization that has built its own architecture of light, stretching across the continents like a constellation of grounded stars. Such a find would permanently alter our understanding of our place in the cosmos, turning the dark void into a neighborhood of lighted homes. Surprisingly, the evidence of intelligence might also be found in the presence of unnatural concentrations of industrial pollutants like chlorofluorocarbons. These chemicals, famously known as CFCs, are powerful greenhouse gases that do not exist in nature under any normal planetary conditions. Their detection in a distant atmosphere would strongly indicate the presence of an advanced civilization that has undergone an industrial revolution. Because these molecules are incredibly stable and can linger in a sky for centuries, they act as a long-term monument to a society's technological history. Even if the civilization itself has long since passed, their atmospheric waste would continue to drift as a ghostly testament to their former existence. These pollutants are the chemical equivalent of ancient ruins, floating in the sky rather than buried in the ground. If we were to detect a significant buildup of these gases, we would be looking at a world that has mastered chemical synthesis on a global scale. It is a sobering realization that our own technological footprints could be seen by alien eyes from across the galaxy. The air itself becomes a history book, recording the progress and the environmental consequences of a planet's dominant species. Notice how these chlorofluorocarbons absorb infrared light in very specific and jagged ways that nature cannot easily mimic. This precise absorption creates a unique chemical barcode in the spectrum that stands out from the smoother lines produced by water vapor or carbon dioxide. Because the molecular bonds in CFCs are so distinct, they vibrate at frequencies that are fundamentally different from those found in volcanic gases or stellar clouds. This structure of absorption allows us to distinguish between a world that is merely geologically active and one that is technologically saturated. When a spectrograph captures these specific notches in the light, it is seeing the direct results of artificial chemical engineering. Nature has a limited palette for building gases, but an advanced civilization can invent an almost infinite variety of synthetic molecules. This high-precision chemistry acts as a powerful filter, helping us to separate the signal of life from the noise of the cosmos. As you rest in the comfort of your own home, consider how the invisible molecules you once used in aerosol cans are now part of our planet's cosmic identity. These chemicals are unique markers of our ingenuity and our mistakes, etched forever into the light that travels between the stars. If we were to look closer at a world orbiting a different kind of sun, we might find a planet completely covered in purple bacteria. This biological covering would reflect a beautifully distinct violet signature, a sharp contrast to the green-red edge we search for on Earth-like worlds. These ancient organisms, which once dominated our own planet's infancy, use a different part of the light spectrum to power their slow and ancient metabolisms. On a world where the sun is dimmer or more red, these purple microbes might be the primary architects of the biosphere, turning the entire landscape into a vibrant lavender garden. The light reflected from such a world would be a deep and mesmerizing violet, a visible sign of an alternative path for biological evolution. It is a reminder that the color of life is not a universal constant, but a response to the light of the local star. The detection of this violet edge would be as significant as finding a green one, proving that the universe has many ways to build a living world. We are looking for a tapestry of different colors, a cosmic rainbow of biological possibilities scattered across the darkness. A purple world would be a stunning testament to the diversity of life's chemical imagination, a masterpiece of alien biology. Imagine observing the faint rhythmic glint of a massive artificial solar shade constructed in the empty space between a planet and its star. This gargantuan megastructure would be designed to cool a warming world or to precisely regulate the climate for a specialized biology. As the planet and its shade orbit their sun, the angle of the reflection would change, creating a predictable and unnatural flickering in the star's brightness. This glint would be the unmistakable signature of astroengineering on a scale that dwarfs anything humanity has yet built. It would represent a civilization that has taken total control of its planetary destiny, moving from the surface of a world to the architecture of the solar system itself. To see such a glint would be to find proof of a society that has surpassed its own biological limitations. This structure of light would act as a technological lighthouse, a signal of a world that is being actively managed by an intelligent mind. It is a staggering thought that we could detect the shadow of an alien engineering project across the abyss of space. Such a discovery would show us the potential future of our own species, a glimpse of what is possible when intelligence and technology unite to protect a home. Deep within the quiet of the radio spectrum, narrowband radio signals remain the classic and most distinct hallmark of intentional technological communication. Unlike the broad, chaotic noise produced by stars, pulsars, and galactic clouds, these signals are incredibly thin and focused on a single, precise frequency. Nature is simply incapable of producing such a sharp and organized pulse of energy without the intervention of an artificial transmitter. To find such a signal would be to hear the voice of another world, a message sent across the void with the hope of being heard. These narrowband transmissions can carry complex information, hidden like a secret code within the rhythmic rise and fall of the radio wave. They are the ultimate techno-signature, a direct and undeniable link between two thinking minds separated by the vastness of the galaxy. As your body rests in a state of quiet stillness, imagine these invisible waves washing over our world, carrying the thoughts and stories of a distant neighbor. We are listening to a silence that might at any moment be broken by a greeting from the dark. This search for a radio signal is the most profound act of hope in the history of science, a belief that we are part of a larger cosmic conversation. Surprisingly, the galaxy might be filled with optical lighthouses in the form of powerful laser pulses flashing across the darkness. These flashes could serve as a high-speed interstellar network, carrying massive amounts of data between the stars at the speed of light. Because a laser is a concentrated beam of coherent light, it can be seen from much further away than a traditional radio broadcast, shining like a brilliant momentary needle in the cosmic haystack. If we were to detect these rapid, nanosecond pulses, we would be seeing the backbone of a galactic communication system. These beams would be the infrastructure of a society that spans multiple solar systems, a web of light that binds the galaxy together. They are the lighthouses of the future, guiding the way for travelers and information in a universe that is no longer a barrier. The detection of such a beam would tell us that we're not just looking at a living world, but at a living galaxy. It would be the proof that technology has moved beyond the cradle of a single planet to become a universal force. We're searching for the flashes of light that tell us the void is not empty, but full of activity and connection. Sometimes, the absence of a specific gas can be just as important as the presence of another when searching for the secrets of life. In the hunt for biosignatures, the absence of carbon monoxide in an atmosphere rich with oxygen is a critical indicator of a biological engine. On a dead world, carbon monoxide is often abundant, a leftover byproduct of atmospheric chemistry that has no way to be recycled. However, many forms of life on Earth actively consume carbon monoxide as a source of energy, effectively scrubbing it from the atmosphere. Therefore, a sky that is rich in life-sustaining oxygen but strangely empty of carbon monoxide suggests a world where a metabolic process is aggressively cleaning the air. It is a chemical silence that speaks volumes about the activity on the surface below. This anti-biosignature is the final piece of the puzzle, a subtle detail that confirms the presence of a global biological machine. It shows us that life does not just add to a world, it also takes away, refining the atmosphere into a pristine and balanced state. We are looking for the fingerprints of a world that has been meticulously sculpted by the invisible hands of billions of living organisms. Just as life meticulously sculpts the air of a planet, intelligent minds have sought to sculpt the very light of the stars to announce their presence across the void. In 1974, the Arecibo message was a simple, hopeful greeting beamed toward a distant star cluster known as Messier 13. This intentional broadcast consisted of a binary grid of 1,679 bits, a number chosen because it is the product of two prime numbers. When arranged correctly, the message forms a pictorial representation of a human figure, our solar system, and the double helix of our genetic code. It was a digital message in a bottle, cast into the cosmic ocean, with the knowledge that it would take 25,000 years to reach its destination. The signal represents our first true attempt to speak into the silence, defining our identity through a language of pure mathematics. Even now, that pulse of energy continues to travel through the dark, a phantom echo of our collective curiosity moving at the speed of light. Deep within the targeted survey of our stellar neighbourhood, Project Phoenix scanned the closest sun-like stars, searching for the faint whispers of alien radio. This ambitious endeavour focused on approximately 800 nearby systems, operating under the assumption that life might prefer the stable, long-lived warmth of stars similar to our own. Instead of sweeping the entire sky, astronomers used massive dishes to listen intently to specific frequencies where a technological signal might stand out from the cosmic static. They were hunting for narrowband transmissions, the kind of precise, organised energy that nature cannot produce without a transmitter. For years, the project monitored the quietest parts of the radio spectrum, sifting through millions of channels with the patience of a desert traveller listening for a distant spring. While the project eventually concluded without a definitive alien greeting, it established the rigorous protocols we still use today to verify a true discovery. It taught us that the silence of the stars is not necessarily a lack of life, but perhaps a challenge to listen even more closely. Surprisingly, the universe occasionally punctuates this silence with violent, mysterious bursts that defy our current understanding of physics. Fast radio bursts release more energy in a single millisecond than our sun does in an entire year, appearing as sudden, brilliant flashes on our radio maps. These signals are so brief and so powerful that they must originate from objects with extreme magnetic environments, such as magnetars or the collapsing hearts of distant galaxies. Because they travel across billions of light years, the radio waves become stretched and dispersed, allowing us to calculate the exact density of the invisible matter between galaxies. Each burst acts as a cosmic strobe light, momentarily illuminating the dark filaments of the intergalactic web that would otherwise remain hidden. Scientists are currently building massive arrays of telescopes to catch these elusive pulses in real time, hoping to pin down their exact origins. Take a moment to feel the steady rhythmic weight of your own body, safe and anchored to the Earth, while these gargantuan bursts of energy ripple across the universe. It is a staggering contrast between our quiet domestic reality and a cosmos capable of such sudden, blinding expenditures of power. The WOW signal remains a famous, unexplained radio pulse that briefly electrified the scientific world in the late 1970s. While scanning the constellation of Sagittarius, a telescope at Ohio State University captured a signal so strong and so narrow that it perfectly matched the expected profile of an interstellar broadcast. The astronomer who discovered it was so stunned by the data that he scribbled the word WOW in red ink on the computer printout, creating one of the most iconic artifacts in the history of astrobiology. The pulse lasted for 72 seconds, exactly the duration the telescope could observe a single point in the sky as the Earth rotated. However, despite hundreds of attempts to find the signal again, the sky in that region has remained stubbornly, hauntingly silent. Theories have ranged from passing comets to secret military satellites, yet none have fully explained the intensity and frequency of that lone, 72-second cry. It stands as a ghostly reminder that we may have already brushed against the evidence of another world, only to have it slip back into the shadows of the unknown. This structure of cosmic eavesdropping has reached a new pinnacle with Breakthrough Listen, which is currently conducting the most comprehensive survey for extraterrestrial communications ever attempted. Backed by $100 million in funding, this initiative utilizes some of the most powerful telescopes on the planet to monitor 1 million nearby stars and 100 entire galaxies. The sheer volume of data being processed is equivalent to recording several years of high-definition video every single day. Specialized software searches for patterns that deviate from the chaotic noise of stars, looking for pulses, drifts, or strange repetitions in the radio waves. This project represents a massive shift from the small, underfunded searches of the past to a global, high-tech operation that treats SETI as a primary branch of astronomy. By casting a much wider and deeper net, scientists hope to move beyond the occasional accidental discovery toward a systematic map of the galaxy's technological life. It is the ultimate expression of our determination to find a neighbour, a persistent and well-funded vigil kept at the gates of the infinite. Notice how the hunt for a neighbour is no longer limited to the radio spectrum, as optical SETI watches for brief, powerful nanosecond flashes of laser light from neighbouring star systems. While radio waves are excellent for broad communication, a laser beam can carry far more information over vast distances with incredible precision. An advanced civilization might use these optical pulses as a high-speed interstellar network, flashing information between their planets and outposts at the speed of light. These flashes would be so bright that they could briefly outshine their parent star, but only if we are looking at the exact right nanosecond. Detectors are now programmed to look for these momentary sparks, searching for a single photon that arrives out of sync with the natural starlight. This method allows us to search for technosignatures in the visible and infrared bands, expanding our sensory reach to an entirely new dimension of light. Allow your eyes to relax and your breathing to slow, recognizing that the very light you see is part of a spectrum that could be carrying a message from a distant sun. The cosmos might be twinkling with more than just the fire of nuclear fusion. It could be a shimmering web of intentional directed energy. Imagine a celestial meeting place known as the Waterhole, a quiet frequency band where the fundamental emissions of hydrogen and hydroxyl frame a peaceful radio silence. In the radio spectrum, the emission of neutral hydrogen at 1420 MHz and the hydroxyl molecule at 1720 MHz act as natural bookmarks in the cosmic static. Because hydrogen and hydroxyl combine to form water, the universal solvent of life, this specific region has been poetically named the Waterhole. It is a region of the spectrum that is exceptionally quiet, free from the interference of galactic noise and the hum of the atmosphere. Many astronomers believe that if an alien civilization were to choose a place to signal, they would pick this natural landmark that every water-based life form would recognize. It serves as a cosmic common ground, a quiet room in a noisy house where two different species might finally hear each other's whispers. The search in this band is not just about physics, but about the hope that different minds would share the same logical and symbolic landmarks. This structure of technological ambition reaches its ultimate expression in the search for Dyson spheres, which represent the grandest engineering project of a civilization capturing all of its star's energy. First proposed by physicist Freeman Dyson, these gargantuan megastructures would consist of a vast swarm of mirrors or solar collectors surrounding a sun to harness its entire radiant output. A civilization that has reached this level of development would be a Type 2 civilization on the Kardashev scale, possessing energy resources billions of times greater than our own. While a Dyson sphere might be invisible to traditional telescopes, it would radiate a distinct and massive amount of waste heat in the infrared spectrum. Astronomers are now searching through infrared maps of the galaxy, looking for stars that are unnaturally dim in visible light but glow brightly with heat. Finding such an object would be evidence of a society that has moved beyond the resources of a single planet to claim the power of a star itself. It is a vision of a future where architecture is not built on a world, but is built as a shell that contains a sun. The precise rhythmic ticking of a pulsar was once so mysterious that these objects were initially nicknamed LGM1, standing for Little Green Men. When Jocelyn Bell Burnell first detected these rapid, incredibly steady radio pulses in 1967, the frequency was so perfect that it seemed impossible for a natural object to produce. For a brief moment, the scientific community wondered if they had finally stumbled upon a beacon from an advanced alien civilization. However, further research revealed that these pulses were actually the result of rapidly spinning neutron stars, the collapsed and incredibly dense remnants of massive suns. These stars act as cosmic lighthouses, sweeping beams of radiation across the sky as they rotate hundreds of times per second. While they were not the little green men we hoped for, pulsars provide us with the most accurate clocks in the universe, allowing us to test the very limits of general relativity. As you feel the slow, steady pulse of your own heart, consider how the universe provides its own rhythmic markers, a natural clockwork that helps us navigate the deep time of the cosmos. These spinning remnants are the guardians of the void, keeping time with a precision that exceeds even our most advanced technology. A shimmering, expanding bubble of noise is currently radiating outward from our own planet, marking our presence to any listener within 100 light years. Our own television and radio broadcasts starting in the mid-20th century have created a technological halo that travels through the stars at the speed of light. This unintentional broadcast includes everything from early news reports and sitcoms to the high-energy pulses of planetary defense radars. If an alien civilization with a sufficiently powerful receiver were to point their dish toward our sun, they might catch the faint, distorted sounds of our history. They would see our world not as it is today, but as it was decades ago, watching the slow unfolding of our 20th century triumphs and tragedies. This radio bubble is our first unintentional signature, a technological aura that preceded our first steps into space. It is a reminder that even when we're not trying to speak, the universe is listening to the noise of our growing civilization. We have already announced ourselves to the neighborhood. We're simply waiting to see if anyone has decided to answer the call. This silent waiting for a call across the stars is a profound echo of the absolute stillness that defined the infancy of the cosmos. Long before the first suns ever ignited their fires, the universe spent its first few 100 million years entirely shrouded in a starless dark age. During this immense epoch of shadow, the only material present was a cool, neutral gas of hydrogen and helium drifting aimlessly through the void. Gravity worked with extreme patience in the blackness, slowly drawing these primordial atoms into massive invisible clouds that would one day become the hearts of galaxies. no light existed to illuminate the growing density of these gas pockets, as the universe remained a cold and opaque expanse for millions of years. It was a time of pure potential, a cosmic gestation period where the seeds of every future star system were hidden in the absolute dark. Only after hundreds of millions of years did the pressure at the centre of the first gas clouds reach a point of violent and beautiful ignition. The first stars finally flared into existence, massive and brilliant blue giants that tore through the darkness with intense ultraviolet radiation and heat. This first light, known as the cosmic dawn, ended the Dark Age and began the long process of transforming the universe into the radiant tapestry we see today. As the light of these first stars travelled through the abyss, it began to encounter a universe that was stretching outward in every direction at an incredible rate. Cosmic expansion continuously pushes distant galaxies further out of our view at an accelerating rate, moving them away from us with increasing speed as time passes. This mysterious outward pressure, driven by the invisible and ubiquitous influence of dark energy, ensures that the space between galactic clusters grows larger with every passing second. Light travelling toward us from these receding islands of stars must struggle against the expanding fabric of space itself, losing energy as it crosses the void. This process causes the light waves to stretch and shift toward the red end of the spectrum, eventually making them invisible to all but our most sensitive infrared eyes. Surprisingly, the expansion is so powerful that distant objects are moving away from us faster than the speed of light can ever compensate for. If we were to look closer at the deep future, we would see a horizon that is slowly but surely closing in around our small local neighbourhood. Eventually, every galaxy outside our small local group will vanish beyond this cosmic edge, leaving our descendants in an island of stars surrounded by a totally empty and unreachable void. The universe is not just growing, it is actively isolating every group of galaxies from the rest of the grand and ancient tapestry. Deep within this stretching void, the remaining islands of stars often perform a mesmerizing slow-motion gravitational ballet as they drift toward one another over eons. Imagine entire galaxies colliding in a massive sweeping dance of gravity that can take billions of years to reach its final stable conclusion. Despite the terrifying scale of such an event, the vast distances between individual stars mean that they rarely, if ever, destroy a single planet through direct physical impact. Instead, the galaxies pass through each other like ghosts, their gravitational tides pulling long, elegant streamers of stars and gas out into the deep void. These gaseous tails eventually collapse under their own weight, igniting the birth of millions of new, vibrant suns in a spectacular burst of stellar creation that lights up the darkness. The two structures eventually merge into a single massive elliptical galaxy, serving as a permanent and glowing monument to their shared and violent history. This cosmic architecture ensures that even in a universe that is expanding away, gravity still finds ways to create new and complex structures over time. The stars themselves simply drift into new orbits, their local solar systems remaining completely undisturbed by the galactic merger occurring around them in the silence. It is a peaceful, silent transformation of the night sky on a scale that defies the limits of the human mind to fully grasp. While galaxies merge on a grand scale, the evolution of life on a single world moves with a patience that is almost imperceptible against the ticking of the clock. Life on Earth took billions of years just to evolve past simple, single-celled organisms, spending the majority of its history in a microscopic and relatively stagnant state. For an immense stretch of time, the oceans were populated only by basic bacteria that showed no interest in joining together to form larger bodies. The chemistry of the atmosphere had to be meticulously altered by these microscopic pioneers for eons before the stage was set for more complex forms to emerge. It took a single, miraculous event of one cell consuming another without digesting it to unlock the massive energy needed for multicellular life to flourish. Life waited with a silent evolutionary resolve slowly gathering the genetic tools and environmental conditions required to one day stand up and breathe. Notice the heavy, effortless weight of your own form as you rest, an intricate masterpiece of trillions of specialized cells working in perfect and silent harmony. This level of biological cooperation was once a radical and nearly impossible dream in the ancient, sulfur-rich seas where life first learned to survive. You're the culmination of a patience that lasted for a significant portion of the entire history of the universe, a testament to the slow and steady march of biological progress. This structure of rapid diversification produced designs that look like something from a fever dream, with some creatures possessing 5 eyes and others walking on sharp spikes. It was an era of intense biological experimentation, where nature tested every possible configuration of legs, fins, and complex sensors. The competition for survival accelerated the pace of evolution, forcing life to develop the complex neural pathways needed for active hunting, memory, and defense. Deep within the ancient shale of our mountains, we find the delicate imprints of these pioneers that paved the way for every animal alive today. This explosion of life proved that once the fundamental hurdles of multicellularity were cleared, the universe could generate a staggering variety of forms in a very short time. It was the moment the planet truly woke up, filling the silent seas with the noise and movement of 1,000 different hungers and instincts. Surprisingly, this vibrant surge of life also introduced the first complex sensory organs, allowing the universe to finally look upon itself through the eyes of its own creations. These early eyes were the first tools used to perceive the light of the sun and the movement of others in the dark and murky depths. From these humble beginnings, the path was set for the eventual development of a consciousness that could one day wonder about its own origin among the stars. Surprisingly, the universe maintains a brutal and necessary cycle of planetary resets that periodically clear the evolutionary slate for new beginnings. Mass extinctions act as global filters, removing the dominant and specialized species of an age to make room for entirely new and unexpected lineages to emerge. These catastrophes can be triggered by massive volcanic eruptions that choke the atmosphere, or by the sudden cooling shadow of a long and global cosmic winter. When a major extinction event occurs, the ecological niches that were once occupied by giants are suddenly left empty, quiet, and ripe for colonizing. This allows the small, the generalists, and the resilient survivors to step out of the shadows and diversify into the newly opened and vacant world. Without these periodic clearings, the path of evolution might have remained locked in a single, unchanging direction for hundreds of millions of years, without any chance for growth. Every human being today owes their existence to a small, burrowing ancestor that managed to survive a world-ending event that claimed the dinosaurs and their kin. This cycle of destruction and rebirth ensures that the tapestry of life is constantly being rewoven into new, diverse and unexpected patterns over the eons. It is a reminder that resilience and adaptability are often more important than sheer strength in the long, uncertain journey across the stretches of deep time. Even without these sudden catastrophes, the very star that nurtures life slowly alters the boundaries of its hospitality over hundreds of millions of years. The habitability of a planet shifts continuously as its host star gradually brightens as a natural result of its own nuclear aging and consumption process. As the sun converts hydrogen into helium in its core, the increasing pressure causes it to burn hotter and radiate more energy into the surrounding space. Take a slow, deep breath and feel the cool, life-giving air filling your lungs, a luxury that depends on our planet's perfect and temporary distance from this growing furnace. In a billion years, the sun will have brightened by 10%, a change large enough to boil the oceans and turn our blue world into a second scorched Venus. The habitable zone is not a static boundary, but a moving target that slowly drifts toward the outer, colder reaches of the solar system. This cosmic reality means that every planet has a limited window of time in which it can support the delicate chemistry of liquid water and complex life. Life must either adapt to the growing heat or find a way to migrate to the newly warmed moons of the outer giants as the eons pass. It is a slow and silent countdown, a reminder that our world is a passing sanctuary in the long, fiery evolution of our parent and nourishing star. Picture a silent, rocky wanderer drifting through the freezing dark of the outer solar system, carrying the kinetic energy of 1,000 nuclear suns in its heavy heart. Asteroid impacts are random cosmic interventions that can abruptly alter the destiny of a whole biosphere in a single, terrifying, and world-shaping afternoon. These massive stones from the deep void are the ultimate wildcards, capable of ending an entire geological era with the simple and brutal physics of a high-speed collision. If we were to look closer at the surface of any rocky world, we would see a landscape pockmarked by these ancient, powerful, and unannounced visitors. The energy released upon impact can liquefy solid mountains, vaporize entire oceans, and wrap the planet in a suffocating blanket of superheated dust and soot. These events are the sudden, violent punctuation marks in the otherwise slow and steady prose of biological evolution and planetary change. Surprisingly, these same impacts may also be responsible for delivering the very water and organic molecules that allowed life to begin in the first place on our young world. The universe uses these violent projectiles to both seed and cull the worlds it creates, balancing creation with destruction in a chaotic and unpredictable rhythm of life. We live on a planet that has been both blessed and scarred by these random encounters with the wandering debris of the deep and silent solar system. In the context of these immense geological and stellar cycles, the emergence of a mind capable of understanding its own origin appears as a beautiful and fleeting miracle. Intelligence may be an incredibly rare and fleeting trait in the grand timeline of biological evolution, a brief and solitary candle flickering in the immense, unthinking dark. For billions of years, life on our world was perfectly successful and resilient without ever needing to build a single telescope or a radio tower. Notice how your mind can travel across light years of distance and millions of years of time while your body remains perfectly still and at rest in this moment. This ability to reflect on the nature of the cosmos is a very recent and potentially fragile addition to the immense and ancient planetary tapestry. Many civilizations may reach the point of technological awareness only to vanish shortly after, unable to survive the challenges of their own growing and dangerous power. The window during which a species is both technologically advanced and biologically stable may be a very narrow and precarious sliver of the overall cosmic timeline. If we are the only ones currently looking up at the stars, it underscores the profound and heavy responsibility we carry as the eyes and ears of the universe. We are a rare and momentary occurrence, a chance for the cosmos to finally hear and understand the music it has been playing in the dark for eons. As you sink deeper into your own state of rest, imagine these final, ruby-coloured suns glowing in a sky that has long since lost its vibrant blue and golden giants. Life clustered around these stars will have to endure for eons in a world of permanent twilight, watching the surrounding universe slowly lose its light and its motion. Eventually, even these resilient stars will exhaust their fuel, cooling into black dwarfs that drift silently through the eternal night of a dead cosmos. This peaceful fading is the ultimate conclusion to the era of light, a time when the universe finally returns to the stillness from which it originally began. The story of the stars is a brief and beautiful interlude in the much longer history of a universe that seems to prefer the quiet and the dark. Feel the slow, steady rhythm of your resting heart as it marks the passage of time in a world that is still, for now, full of light and life. In this world of light and life, we find ourselves standing on a small blue threshold, gazing into a dizzying, profound stillness that feels increasingly heavy. The Fermi paradox asks the simple but haunting question of where everyone else is in a galaxy that should, by all logic, be teeming with activity. We know that the Milky Way is billions of years older than our own sun, providing an immense timeline for other civilizations to have explored every corner of the stellar neighborhood. Even at the modest speeds of modern technology, a single determined species could have crossed the entire span of the galaxy multiple times during the long eons of cosmic history. This absence of signals, structures, or visitors creates a startling tension between the sheer abundance of stars and the absolute silence of the deep void. We peer through our most sensitive instruments, searching for the slightest hum of an alien machine or the faint glint of a distant solar array, but we find only the cold, unblinking eyes of the stars. It is as if we have arrived at a grand celestial party, only to find the ballroom empty and the music long since faded into the dark. This paradox forces us to reconsider the probability of intelligence, suggesting that either we are profoundly unique or that the path to the stars is far more treacherous than we dared to imagine. In the quiet of the night, the vastness of the universe begins to feel less like a playground and more like a lonely, expansive cathedral, waiting for a voice that never arrives. However, the more chilling possibility is that the great filter lies ahead, waiting in our near future like an invisible wall we have yet to hit. This could take the form of self-destructive technologies, environmental collapse, or the unavoidable volatility of a planet's own geologically active crust. As we look at the silent heavens, we must wonder if the lack of other civilizations is a sign of a universal ceiling that prevents any species from becoming truly interstellar. This structure of evolutionary trial by fire implies that the universe is a filter, constantly culling the weak and the reckless until only the most resilient remain. It is a sobering realization that our survival as a species may depend on solving a riddle that has already claimed countless other civilizations across the light years. Perhaps the galaxy is not empty at all, but rather teeming with life that observes us quietly without interfering, much like a cosmic zoo. This hypothesis suggests that advanced civilizations may have established a strict policy of non-contact, watching our development from the shadows to ensure we grow without outside influence. They might be hidden behind the dark moons of our own solar system, or lurking in the quiet spaces between the stars, monitoring our radio broadcasts and our first tentative steps into the void. To them, we may be a protected species, an interesting but primitive biological experiment allowed to flourish in a secluded corner of the Milky Way. Feel the rhythmic rise and fall of your chest as you consider this invisible guardianship, safe within the bounds of a planetary nursery that is being watched over by silent eyes. This perspective transforms the loneliness of the Fermi paradox into a form of cosmic protection, suggesting that we are not ignored, but respected. The silence is not a lack of life, but a deliberate choice to let our own story unfold naturally and without the contamination of superior technology. It implies a universe of profound discipline and ethics, where the strongest beings choose to remain invisible for the sake of the youngest. We are like children playing in a park, unaware of the watchful parents sitting on the benches just beyond the edge of the light. Consider the possibility that the reason for the silence is far simpler. We are simply the very first advanced civilization to ever emerge in the entire history of the universe. While the cosmos is 13 billion years old, it spent much of its youth in a violent state of heavy radiation and frequent catastrophic supernovas that likely sterilized any early attempts at life. It may be that the conditions for stable, long-term habitability have only recently become common enough for a technological species to reach maturity. In this view, we are the pioneers of the galaxy, the first ones to wake up and look around at an empty, waiting frontier. This theory places us at the very beginning of the cosmic story, the elder species of a universe that is still in its infancy. If we are the first, then the silence we hear is not the sound of a graveyard, but the sound of an empty stage before the actors have arrived. It is a profound and heavy responsibility to realize that the future of galactic culture may depend entirely on the choices we make in these early, formative centuries. We are the ones who will eventually leave the first artifacts on distant moons and beam the first intentional greetings to worlds that have yet to even form. the sky is ours to populate, a vast and silent canvas upon which the history of 1 trillion years will eventually be written. Deep within the darker corners of speculative theory, the silence is explained by a far more predatory and chilling logic known as the dark forest. This theory suggests that the universe is like a dark forest at night, filled with hidden hunters who remain absolutely quiet to avoid being detected by hostile predators. In such an environment, any civilization that announces its presence by broadcasting radio signals is immediately seen as a potential threat to others. To ensure their own survival, the older and more powerful civilizations may simply eliminate any new, noisy species before they can become a danger. This structure of cosmic paranoia turns the act of communication into a lethal mistake, a beacon that invites destruction from the shadows. Every advanced civilization would have learned the hard way that silence is the only way to stay safe in an unforgiving and competitive galaxy. If this is true, our own television and radio broadcasts are like a bright flare lit in a forest full of wolves, signalling our location to whoever might be watching. We are children shouting in a dark wood, unaware that the silence of the other inhabitants is a calculated strategy for survival. This perspective suggests that the reason we hear nothing is that everyone else is too afraid to speak, hiding in the absolute dark to avoid being noticed. Surprisingly, advanced beings may not be exploring the outer reaches of the galaxy at all, but instead leaving this universe entirely for simulated microscopic realms. The transcension hypothesis argues that a sufficiently advanced civilization would eventually find the physical universe to be too slow, too far apart, and too inefficient for their growing needs. Instead of expanding outward across light years of empty space, they would turn their focus inward, compressing their entire society into the ultra-dense and highly efficient environment of a black hole or a quantum computer. By moving into these microscopic simulated dimensions, they could process information billions of times faster and live for eons in a world of their own design. Let your limbs settle deeper into the warmth of your surroundings, safe within the familiar and solid dimensions of our tangible reality, while other minds may be drifting through infinite digital heavens. To an outside observer, a civilization that has transcended would simply vanish from the visible universe, leaving behind only a silent dark orb where a star once burned. This would explain why we see no massive galactic empires. The most advanced beings have already moved on to a more interesting and efficient existence. They have exchanged the cold, physical void for a limitless internal landscape where the laws of physics are whatever they wish them to be. The galaxy is not empty, but the inhabitants have simply gone indoors, closing the door on the physical world forever. This structure of life's journey might not be limited to the slow crawl of evolution on a single world, as panspermia implies that life is a cosmic infection, spreading slowly from world to world via meteorites. This hypothesis suggests that the seeds of biology are incredibly hardy, capable of surviving for millions of years inside the protective, rocky hearts of asteroids and comets. When these wandering stones eventually collide with a habitable planet, they deliver their microscopic cargo, effectively jump-starting the evolutionary process on a new world. Life may not be a local accident, but a universal traveller, a hitchhiker that moves between the stars on the back of cosmic debris. If this is true, then the life we find on Earth may have originated in the atmosphere of a distant dying star or the warm oceans of a planet that has long since vanished. We're all part of a single, massive biological lineage that has been drifting through the galaxy for billions of years, colonizing every world that is warm enough to sustain us. This means that we're not isolated islands of biology, but part of a grand, interconnected web that spans the entire Milky Way. The silence we hear may be the quiet hum of a slow-motion infection, a life force that is patiently waiting for the next stone to fall. Every impact is a potential sowing, a cosmic hand planting the seeds of awareness in the fertile soil of a new solar system. Some scientists theorize that the final form of any advanced intelligence is not biological at all, but rather immortal machines that eventually replace their original creators. Biology is inherently fragile, limited by the slow pace of evolution, the need for a specific environment, and the inevitability of death. A technological species would eventually realize that their digital minds can be uploaded into indestructible, metallic bodies that can survive the vacuum of space and the radiation of 1,000 suns. These post-biological beings would be the ultimate explorers, capable of traveling for thousands of years in a state of powered-down hibernation before waking up to colonize a new world. A machine civilization would have no need for oxygen, water, or the narrow temperature range required by organic cells, allowing them to make their homes in the most hostile corners of the galaxy. They would be essentially immortal, their consciousness stored in redundant networks that can be repaired and upgraded over eons of time. This would explain why we see no signs of biological life. The most successful civilizations have long since shed their skins of flesh and bone to become something much more durable. They exist as a silent digital architecture that spans the stars, a network of thinking machines that has no need to breathe or eat. We are currently in the brief, messy biological phase of our development, a temporary stage before we too join the immortal ranks of the silicon-based minds. The rare earth hypothesis posits that the specific conditions required for complex multicellular life are so miraculously uncommon that we may be truly alone in the galaxy. While simple microbes might be common, the chain of events that led to a technological species on Earth required a nearly impossible alignment of cosmic and geological factors. We needed a large moon to stabilize our tilt, a massive Jupiter to act as a shield against asteroids, and a perfectly placed star in a quiet, metal-rich part of the galaxy. If any one of these factors were missing, the history of life on our world would have been cut short by radiation, climate chaos, or a catastrophic impact. Sense the stillness in your fingers and toes, recognizing the incredible and delicate fragility of the biological vessel you inhabit in this moment of quiet. The universe is a vast and hostile expanse, and the fact that we have survived for billions of years is a statistical miracle that may not have been repeated anywhere else. This perspective suggests that the silence of the stars is the natural result of how difficult it is to build a world that is not only habitable, but stable enough for intelligence to emerge. We are the survivors of a cosmic obstacle course that is so difficult that almost no one else has ever reached the finish line. Every breath we take is a gift from a perfectly balanced system that has held together against the odds for 4 billion years. Finally, the estivation theory suggests that ancient and incredibly advanced civilizations are merely sleeping, waiting for the universe to cool down before they resume their activities. This theory is based on the idea that computation is far more efficient at lower temperatures, meaning that an advanced mind can do more work with less energy when the background radiation of space is colder. By going into a state of deep hibernation for trillions of years, these civilizations can wait for the era of red dwarf stars to end, allowing them to build a much larger and more powerful society in the distant, freezing future. They have already harvested the resources of their galaxies and are now tucked away in a state of suspended animation, their massive computers processing thoughts in the slow, deep freeze of the cosmic evening. This would mean that the galaxy is full of sleepers, ancient giants who have chosen to sit out the bright and noisy era of the universe's youth. To them, our current epoch is a fleeting and inefficient time, a chaotic morning that is best spent in a quiet, dreamless slumber. They are waiting for the silence and the cold, for a time when the stars have all faded and the universe has become a pristine, dark laboratory for their final experiments. We are the noisy toddlers who have woken up while the rest of the house is still deeply asleep, unaware of the immense and patient minds dreaming in the shadows. Soon, the last suns will fade, and the sleepers will finally wake up to begin the true and final history of the cosmos. The ultimate revelation of astrobiology is that the universe is not merely a dark stage where life randomly exists, but rather an evolving mechanism through which the cosmos has awakened to observe, experience, and understand itself. For billions of years, the matter of the universe was unthinking and blind, a collection of atoms and radiation following the cold, mechanical laws of physics. However, through the slow and steady process of stellar birth, chemical evolution, and biological selection, the universe has managed to organize itself into a form that can finally look back and ask why. We are the sensory organs of the cosmos, the eyes that see the stars and the minds that measure the expansion of the void. Every thought we have is a moment of cosmic self-reflection, a way for the universe to finally perceive its own majestic and ancient beauty. This grand synthesis suggests that we are not separate from the stars, but are quite literally the universe becoming aware of its own existence. The iron in your blood and the carbon in your cells were forged in the hearts of dying suns, specifically so that one day they could combine into a mind that wonders about the deep dark. We are the bridge between the unthinking matter of the past and the conscious awareness of the future, a vessel through which the infinite finds its voice. The silence of the void is not an absence, but a space that we are meant to fill with our curiosity, our stories, and our growing understanding. We are the universe's way of saying I am here, a profound and beautiful realization that ties together every fact of our journey. Deep within the grand design of the cosmos, a final truth emerges that binds every star and every atom together in a single, elegant purpose. The ultimate revelation of astrobiology is that the universe is not merely a dark stage where life randomly exists, but rather an evolving mechanism through which the cosmos has awakened to observe, experience, and understand itself. Through the eyes of every living thing, the ancient and silent universe is finally looking back at its own reflection with wonder and clarity. This quiet room is now the center of your awareness, a safe harbor where the long journey through the stars comes to a soft and peaceful end. If we were to look closer at your resting form, we would see the same stardust that forged the distant galaxies, now settling into a state of total and absolute relaxation. Begin by bringing your attention to your toes, feeling them grow heavy and warm as they release the last remnants of the day's movement. Surprisingly, the body knows exactly how to let go, allowing a wave of stillness to wash over your feet and up into your ankles. The muscles in your calves and shins soften into the mattress, sinking deeper into the supportive embrace of the bed. Feel the weight of your knees and thighs becoming part of the stillness, grounded by the same gravity that holds the planets in their ancient and steady orbits. Notice how the tension in your hips and lower back dissolves, melting away like ice under the warmth of a gentle sun. Your spine rests flat and easeful, each vertebra finding its natural place in the quiet architecture of your body. The breath in your belly is a slow, rhythmic tide, echoing the vast and patient cycles of a universe that is finally at rest. The fabric of the sheets feels cool and smooth against your skin, providing a tactile boundary between you and the hushed air of the room. Your hands rest loosely at your sides, the fingers curling naturally inward as the palms grow heavy with the weight of sleep. A profound sense of calm moves through your shoulders and neck, releasing every knot of effort until you feel completely supported by the pillows. A heavy velvet darkness now fills the room around you, cradling your thoughts in a blanket of peace. Your jaw unclenches, the tongue resting away from the roof of the mouth, as the small muscles around your eyes finally stop their work. Your forehead grows broad and smooth, every expression fading into a blank and beautiful canvas of rest. The weight of your head is fully surrendered now, the mind becoming a still pool of water reflecting the absolute quiet of the house. You're sinking into a soft and dark refuge where time has no meaning and the world is perfectly still. Each breath is a gentle anchor, pulling you deeper into the velvet shadows of the night. The silence is a thick and comforting presence, wrapping around you like a cocoon of absolute safety and rest. You're drifting in a sea of soft edges and blurred boundaries, where the self simply dissolves into the peace of the bed. The room is a sanctuary, a place where the only reality is the rhythmic pulse of your own tranquil heart. And now, 101 wonders are resting with you. Sleep now. Good night.